agenda. We have our official little tiny URL website that has all this information and some more information on there. We're gonna get going pretty quick here in just a couple of minutes with our first two speakers. We'll take a little break, another couple speakers, and have an open discussion. And then I will mute my phone. Good job, Jeffrey. And then we'll break for the plenary lecture. We'll kind of continue that discussion afterwards, a couple more talks, another discussion, another plenary, and then hopefully folks are interested in joining us for a little evening event where we'll have a cocktail making class with a good friend of ours who owns a bar in San Francisco. And we have alcoholic and non-alcoholic recipes that we can learn how to make together. So that is going to be our outline. Josh, anything you want to add?
No, I think we're good.
Sweet. All right, then we will pass it over to our first speaker, and bad guys, which is going to be interesting. I mean, I guess some people might think brown dwarfs are bad guys. I don't know. I'm sure there's still ongoing, rivalries within astronomy, right? I'm sure. All right, so I'll stop sharing and pass it over to
Remember
Dan.
to turn on recording as well. Yeah.
Oh, yes, thank you. We will go ahead and turn back on recording, which we appear to be. Excellent. Dan, take it away.
Sure, I'm going to try sharing my screen. And let's play from start. All right. So the objective of this talk is to share a little bit about what we've been doing looking for brown dwarfs, because it's fun, and a little bit about what we've been doing looking for bad guys, because it's fun. And for those of you who are considering entering the field of data science, I hope drawing some similarities between these two examples can sort of connect you with what the industry looks like and gives you a little more confidence going into it. The general message is it's all the same thing and you're going to do great. So a little bit of a background about me. I am not a real astronomer and I am not a real data scientist. I am a security researcher, computer security researcher. I work at a company called Gigamon on the applied threat research team. Our role is to improve our product, to find malicious activity in customer environments, and to hunt for it ourselves. Before that, I worked at FireEye. I worked at UC Berkeley and a small consulting company doing a variety of reverse engineering, exploit development, that sort of thing. I got into astronomy through a citizen science project, Backyard Worlds. So Backyard Worlds, the big idea here is that we want to find brown dwarfs and maybe a planet. And we have all these great images from this WISE survey. So let's throw humans at it. The machines aren't working great, so let's throw humans. And that's how it started. It's been a really supportive environment, and that's what kept me in it. But bad guys. So these three in particular are from Fin 7. Now, Fin is short for financially motivated actor. You'll find naming in the security industry is maybe not quite as bad as astronomy, but it's bad. Financially motivated actors, they're after money. So credit cards, namely credit cards, stealing information to sell. They have one thing in mind: getting in, getting money, getting out. And this is how it typically goes. Fin 7 has been out and about way too much. And they typically operate by picking a business that they think is a nice target. To be a nice target, you would handle a lot of credit card data. Ideally, you would not use the chip and pin, whatever they call it, the old style credit cards. They would identify your business and they would launch what you call a spear phishing campaign. So they'll send you an email. The email will contain a document. The document will contain a macro. And if you've ever wondered what a macro is and you don't know, or you saw that little banner, do you want to enable something, click this button? Are you really, really, really sure you want to do it? Yes or no? Macro is code. So if someone gives you a Word document and you press run this macro, you're running a program that they gave you. And it's a script, yes, but it can call operating system calls to map memory and execute that memory. So it's just code. That's how they get in. And if you get their email and you're a little turned off by all the banners and the warning messages, they're going to call you and they're going to talk to you. Say, hey, we wanted to have our CEO and all our C-levels come down to your hotel and stay. We already contacted so-and-so and your staff. We haven't heard anything back. What's going on? They try to put the pressure on, get you to click the button. When you click the button, they're running. They turned your Microsoft Office into a reverse shell, and they're executing code on your machine in real time. Their objective at that point is to move laterally. So they want to get control across the network, and they want to get to the point of sale terminals. When they get on the point of sale terminals, they install their credit card scraper, just resides in memory. Every time you reboot, it'll turn back on. It looks through memory for what looks like credit card numbers, and they just keep streaming that back home. So that's how they work. And it's not just some guy. Like, this coverage map looks better than my cell carrier. They're a business. They have a call center. They have an HR department. FBI picked up 3 of them. There's tons more. The way they're operating, they're in Ukraine. They send out these job postings and say, hey, do you want to come red team? A red team is someone who's authorized to get access into a network for purposes of testing and proving security. Do you want to come red team for us? We can contract you, no problem. All right, we found a company for you to access. Go gain access to that company. And they maintain this layer of contractors where they can say, the contractors don't really, the contractors can say they don't really know that they're getting access when they haven't been contracted, haven't been hired, but they do. That makes it a lot harder to bring them in. It's not just financially motivated actors. You've heard a lot recently. APT, you'll hear that acronym thrown around. It's Advanced Persistent Threat. So they are people like to use it more because it makes it more important. But what people try to convey in general is that it's a group that they've been tasked to get access to a place, and they're going to keep at it. May take them months, may take them years. They don't care if they do it really slowly or what they have to do. They're eventually going to get in. That's what the advanced persistent threat portion of it means. APT-28 has been outed as being Russian military intelligence, especially this unit number, if it means anything to you. The DNC leak, sabotaging Ukraine's artillery remotely, breaking into the anti-doping portion of the Olympics. That was these guys. They operate just the same as FinCEN, well, maybe not with the call centers and such, but they are a large organization too, and they send spear phishing emails. They drop backdoors and move laterally. A lot of the same stuff. More recently, SolarWinds. APT, who knows what, another Russian one, purportedly, by our intelligence organizations. In this scenario, they compromise SolarWinds. SolarWinds makes these network monitoring products that tons and tons and tons of customers have. This Russian threat actor compromised SolarWinds, put a backdoor in their updates, and when SolarWinds customers updated, they got the backdoor. Now they're executing on over 18,000 companies through this action. That should make you really mad. For contrast, if I executed code on any one US company's server, I go to jail. They did it on 18,000. That's not very nice. Like, I get, okay, it's foreign intelligence. We're out to collect intelligence. Yeah, whatever. We saw them execute plenty, and we saw them actually decommission their backdoors on many of these private companies, but they still ran code. Not cool. How about brown dwarfs? This is YZO855. And it's a little weird. So the 4 nearest systems to our sun, within 8 light years, there's Alpha Centauri. It was discovered a long time ago. Barnard Star, discovered not so long ago. And then these 2 things, discovered 2013, 2014. Why? Well, brown dwarfs, as I'm sure you probably all know better than I do, live more in the mid-infrared, and the instruments that we had in the past weren't really sensitive enough to see in those bands. Now we have it, and we found these things absurdly close. So we want more. This is 0855 again. What is it doing? What is this? Why is it all alone? So channel 1 and channel 2, these are Spitzer colors, if you're familiar. Y's colors, W1 and W2, it's somewhat similar. It's fairly diagnostic of its spectral type, its lateness. So this would be in the late Y regime. Why is it so alone? Why is it so faint in J compared to everything? And are there more things in here we're missing? What's going on? So let's find everything. Let's find the bad guys and let's find the brown dwarfs. So to find brown dwarfs, step 1, we take pictures. And I'm not glossing over any details at all. We just put a camera in space and take pictures. Step 2, make a catalog. We have all these nice pictures. Let's find point sources in these pictures. Let's measure their properties and make a nice row column catalog. We like row column. Shove all that stuff through a classifier. I used XGBoost. And stare at the results. What you're seeing blinking is from a visualization tool we made called WiseView. So these are the WISE images themselves. The orange guy on the right, it's merging 2 bands, W1 and W2, to create a color composite. The more bluer things are stronger in W1 than W2. The more orange things, the converse. So we get false positives a lot. But this tool is great for pressing that button and looking at them very quickly. And our false positives may look like just nothing at all, or may look like something where there was a misread. And every once in a while we get a good one. We've had a lot of success with this straightforward approach. We found thousands of new brown dwarfs. And a couple are weird. This one in particular might go somewhere in here. We'll find out if we get James Webb time, if and when and where. This one, I don't know if you can see my panel thing is blocking it. There we go. This guy over here, going down right, they're really quite tough to see. This one's, who knows what this is? It lives out here. We'll find out in a month if this question mark becomes a cross or if it goes down here more. We'll see. Bad guys. How do we find bad guys? This is sort of a toy version of what a network would look like. You have servers, workstations, laptops, phones, TVs, other phones, things all over the place. And you may be a somewhat small organization. You drop this, you'll drop a sensor to monitor your network. And that'll be it. Or you may be a large organization. Maybe you got to sprinkle your sensors all over the place. Maybe you're distributed and you need to put some at remote offices. Do we need to do? Anytime you do a thing on a computer that goes outside, it goes by a sensor and a sensor records it. So when a bad guy's sending an email, it goes over the wire. Bad guy has his macro download the backdoor from GitHub. and run it. Goes over the wire. Bad guy starts typing commands. Where am I? What machines am I connected to? What's my authentication? That all goes over the wire too. All of this gets recorded. And so on the left, you have just raw hex. And on the right, if you were to interpret it as ASCII, it's the same stuff. This is what a DNS request looks like. So this is sort of, instead of images, this is what we're working with. Well, we take this stuff and we smush it into row column. We parse the protocol, extract protocol features, and make ourselves a nice row column table to play with. So in this scenario, as a DNS request, you can see CDN-0. I don't know, it's probably Netflix thing or what have you. And this is what the parse protocol looks like. So we would extract that string. Shove it all through a classifier. Looks familiar. Then stare at the results. In this case, we have Kerber roasting. It's a authentication attack. And this is our test demo, because we, lo and behold, can't show you actual customer network traffic. But this is the sort of deal. We have a UI to look at the results here, just like we do in astronomy. And then you don't celebrate your results, because whenever you find something, it's bad. This has got multiple red teams. I've said before, red teams are when you hire a team who breaks into networks professionally to break in, and you want them to simulate an adversary. You want them to act like whoever you think you should protect yourself against. And a good red team will do that. And they'll tell you, these are what you had left open. These are the actions you need to take to close them. And larger companies will organize red teams annually or more frequently than that. And we see a bunch of them with this. We get commodity malware, the kind of who doesn't care, but we still need to really get rid of it because it could kind of be bad malware. Like cryptocurrency miner, or the backdoor that could eventually lead to ransomware if someone took interest in it. Commodity stuff. And then state-sponsored APT. Respond to actors who have been attempting to get into our customer networks for years. We start to get accustomed to their methodology, what they like to do, what they're after, and we'll make general tools to catch them, but we'll also make customized ones. So there's a lot of similarity. Security and astronomy have really large data sets. We see trillions of rows a month. And catalogs, at least the ones I've worked with, have billions of rows, probably larger. We aggregate the data. Security converts packets, parses the packets, and makes metadata. Astronomy takes images, parse images, make catalogs. And they're both adversarial. In security, bad guys are trying to get away with something. They know you're looking, and they're trying to get their job done without you catching them. In astronomy, the universe hates you. There's more fun to do. It's not only, here's a catalog, let's shove it through a classifier. There's more diverse, entertaining things to play with. This is an example of a image segmentation, or I guess video segmentation, you might want to call it, model that I'm working on using convolutional neural networks, trying to take a cube of WISE images and find things that are moving. So this is segmenting the video slices for which pixels correspond to the underlying point spread function of this thing. Finding co-moving pairs. What about if something's nearby but not moving very fast, not proper moving very fast, coming straight at you, going straight away? How do we find, can we find that with an image processing system? Can we get something that operates on just parallax alone or something else? For security, there's more problems for sure. So one is classifying encrypted network flows. And by now, that's a lot of them. And many of the wins that I showed you before were from that. We created row call features and row classifiers on top of it, but the underlying data was encrypted network data. Stuff like when is the first time or how long ago is the first time we saw this customer communicate with this destination? When was this SSL certificate created or refreshed? When was this domain registered? What is the periodicity of this communication? What is the sequence of time deltas between packets on this? Or the sequence of bytes going in and out? We can classify an automated attack versus a hands-on attacker. It looks different, even when it's encrypted. It's a fun problem. A device classification. What is this thing on my network? It's not that important at face value, but when you realize you can identify some assets that are really important, like this is a domain controller, if someone gets on it, they get everything. Then suddenly you can start to combine that fact with very weak signals and get powerful detections. And anomaly detection. Most competitors in the field have god-awful applications to security, and they just throw anomaly detection at it. Yeah, it's bad out there. We're attempting to not make it so bad. Maybe it won't work. Maybe it will. I don't know. This is what I'm working on right now, trying to take authentication from a customer environment and find outliers, but specifically allow it to generalize on an environment it hasn't seen. So if we take all of our customers now, we have a few known malicious ones, and that's a couple of these here. Find outliers within the set that we have now, and then if we add a new customer that we haven't seen before, can we still do a good job? So you sort of see these two populations. The blue is the training set, all of our customers except for one, and the green is the held out test set, that customer simulating a new customer. And it's okay, but not great. We really want to see them line up. So that's what I'm working on now. So the final message is, if you work with data, you're going to be great. Have fun. That's it.
Awesome. Thanks, Dan. So we've got a bunch of questions here. You sort of answered Genevieve's question about anomaly detection versus pattern detection. The next three are sort of related, so I'll kind of lump them together because I don't want to eat into our short break too much. But people are asking, where can they learn more about the topic? How can we protect ourselves? And sort of what programs, platforms, and languages would you recommend for someone interested in security?
If you want to protect yourself, in general, keep your applications updated, your products and applications updated whenever there's a security update. Most attacks nowadays come through email. Don't click attachments. Even if someone's really coercing you to click an attachment, verify what's going on. And that's pretty much it. I'd say the other thing is don't get too paranoid about it. You know, there's every single developed country has this intelligence collection capability. If they're intent on accessing X, they're going to access X. For them, it's a business call. How much money does it cost me to access X? Do I profit from that information? Spend the money. So don't go nuts trying to protect yourself from everything. due diligence. On learning security, so data science for security, we see a lot of things. Our pure engineering team uses Spark a lot. We've strayed from that. We are using Athena, which is SQL, for just about everything. And when something cannot be done in SQL, which is exceedingly rare, you'll find compilers that will convert a model to SQL for you. If it can't be done in SQL, we do it typically in Python, but it's in AWS's Lambdas. So it just executes code and you put whatever you want in there. We've built a library, a Python library made for consuming Athena results. So we'll say, write this query to collect these features, pull it down to the Lambda, load it into a data frame that's chunked automatically, streaming from the S3 file, run it through a classifier you made, and send the results out to the customer.
That's great. So we're at time. I want to make sure that we give people a break so you can focus on something more distant than your laptop screen, take a bio break, etc. So we'll take a 10-minute break here. Dan, there's a couple more questions in the chat if you want to answer there or in Slack. A couple of the questions about what people can do in academia now to prepare for such a career. Feel free to answer them in the Slack or in the chat here, but we'll also definitely be talking about that during the open discussion number 1 in about an hour or so. So we're going to take a 10-minute break. We'll be back 5 minutes after the hour. Feel free to chat here or in Slack. Thanks, everyone.
Okay, have a restart to be able to share my screen on this computer. Haven't used Zoom on the work computer because I've been using Discord a lot. All right, it's 2:05, 2:06. So we'll welcome back everyone, and hope you had a good break. We have talk session 2 here now. We're going to have a couple talks. Let's see if well, I'll stop sharing my screen. That's not working either. Okay, well, I'll just introduce that. I believe if I have the schedule up, that would be Ben is going to be talking next. We've had a nice talk about both the geology of data science and some security. I think that's a nice balance here. Now I'm going to, I believe, I don't have the screen up right now, but I believe we're going to be talking about biomedical sciences, if I remember the title right. Ben, are you ready?
Yeah, let's do this. So
okay, go to your screen.
Awesome. All right, so can everyone see my screen? See the presentation? I'll assume from the silence that means yes, otherwise someone would have spoken.
Yes.
All right,
That's
so
good.
hi everyone, I'm Ben Nelson. I'm a data scientist at the Chan Zuckerberg Initiative. And today I'm going to be talking about Meta, which is a research discovery tool for the biomedical sciences. The outline of this talk is I'm going to kind of talk about CZI as a whole and the science initiative as a whole, then dig into what Meta is and what sort of need it's fulfilling, and then a little bit about my work as a data scientist in product analytics. Okay, so the Chan Zuckerberg's overall mission is to build a more inclusive, just, and healthy future for everyone. And this is really embodied by our sort of 3 core initiatives, which is education, justice and opportunity, and science. The education initiative addresses challenges in improving the learning experiences and outcomes for K-12 students. Justice and opportunity focuses on issues surrounding criminal justice reform, housing affordability, and immigration reform. And the science initiative focuses on preventing and eradicating different diseases. And what sets CZI apart from a lot of other foundations out there is that there's this focus on using technology to help solve these challenges. So rather than just awarding grants to these different areas, crossing your fingers and hoping for success, we actually do have technology teams to build tools to see these initiatives through. And so we actually pair engineering with grant making, impact investing, policy work, and advocacy to help accelerate the pace of social progress. For someone working on Meta, I reside within the Science Initiative. And as it was sort of implied from the previous slide, it pertains mostly to the biomedical sciences. And the mission here is to support the basic science and technology that will make it possible to cure, prevent, and manage all diseases by the end of the century. That is the actual mission statement, and it sounds extremely ambitious, and it is. However, biomedical science has made tremendous strides over the past century that has advanced human health. There's a number of examples that I could list, but I think a good recent example is the mRNA vaccine for COVID. And we're hoping to see sort of similar progress like that in the next century. So the end of the century is 80 years away. It's a very long time, and we would like to measure our impact much sooner than that. So as a stepping stone to this goal, in the next 10 years, we'd like to see us accelerate biomedical science with open collaborative models of research. And we believe that we can help to empower biomedical scientists to make discoveries at a fast rate and share them more quickly. We can make an impact in basically 3 different but kind of interconnected ways. So the science team is divided into these 3 teams. There's the program team that supports external researchers through grants and collaborations. This is very typical of a foundation or nonprofit. And then we also have a technology team that builds software, computational tools, and data platforms for scientists. So this is actually building tools to make scientists' research lives easier. And then we have a policy team that engages with patients and the public as partners of the scientific process. A good example of this is a project called Rare as One. And this is a project that supports rare disease communities in their quest for treatments and cures. So I working on Meta, reside within the technology team because it is a tech product that we are delivering. But before I talk about Meta, I did want to highlight a few other tech products that CZI is developing. Again, this is all related to the biomedical sciences. So this first one, Cell by Gene, is an open source tool for exploring single cell transcriptomics data sets. So essentially, this is a visualization tool for single cell data sets. Your single cell data sets may have millions of cells of different types expressing different types of genes. And so this is a tool to enable fast visualizations of this very high dimensional data. IDSeq is an open source software platform that helps scientists identify pathogens in metagenomic sequencing data. So essentially what you can do is upload a sample, whether it be like a swab or blood, to a genetic sequencer. And then IDSeq will essentially comb through terabytes of metagenomic data to identify pathogens, whether it be a bacteria, virus, a parasite, whatever. So you don't need to spin up your own computing cluster in order to do these kind of analyses. All you need is a sequencer and an internet connection, and it does it for you. These last 2 tools, Napari and Starfish, are essentially image analysis tools. So Napari is an interactive multidimensional image viewer for Python. It has all sort of the core features of sort of an image viewer like annotation and layering, but it also connects really well with well-known Python machine learning packages. And Starfish is really specific to basically building image processing pipelines for spatial transcriptomics data. All right, so just to recap everything I just said, there's sort of the higher level, sort of what CZI is all about, and I'm embedded within the technology and sci-tech products team. And now let's talk a little bit about Meta. So Meta is provides a faster way to understand and explore science as it evolves, both at the level of broad research fields and at the level of an individual scientific research interests. So the motivation behind all of this is that in the biomedical sciences, there are roughly 4,000 papers that get published each day. And as the research continues to grow, so does the time it takes for researchers to draw the right insights to create new collaborations and accelerate new breakthroughs. So there's basically a need to process this stream of knowledge so that scientists don't miss out on crucial papers to their research. And this could really only happen if the knowledge is connected and easy to explore, because we can't expect scientists to sift through 90 million papers and find the thing that's going to help them come to a breakthrough. So Meta uses machine learning to analyze and map millions of research papers. And right now we're doing this for articles and preprints, but soon we'll be able to do this for data sets, clinical trials, protocols, which is essentially like a methods paper. So there's all sorts of different entity types that we're able to process and surface with Meta. Here's what Meta looks like. You can just go to the website right now and create an account if you want to. It's completely free. For someone like me who doesn't have a biology background and is curious maybe about like what's the latest research on COVID, and maybe instead of looking at a specific paper, I want to look at review articles or like meta-analyses. I can do that by basically constructing a feed. So this is a feed that's very much like your Twitter feed or your Facebook feed, but in your feed are basically research articles. And on the left side, you can see the different feeds that I may have. I have bone marrow neoplasms, and I have this COVID-19 systematic reviews. And you can see all the new papers here. And these papers may come from different sources like PubMed, the bioRxiv, medRxiv, or publishers that we have agreements with. But how do papers end up in this feed to begin with? Each feed has a particular definition. And here you can see the feed definition for COVID-19 systematic reviews. There's different concepts that I want to look for when searching for each of these papers. So some of these concepts may include systematic review, meta-analysis, and the terms coronavirus, COVID-19, SARS-CoV-2. And you can see from this logic here how this feed is constructed. So basically, each paper has to have a concept that's tagged to it. The concepts that are tagged to it are systematic review, meta-analysis, and then either coronavirus, COVID-19, or SARS-CoV-2. And with this, you could actually specify the names of a journal, names of researchers, so you can have a feed dedicated to a particular researcher or a particular journal. All right. So how do we actually go about populating a feed in Meta? So here's an example of how we would basically get a paper out in the public domain and get it into a particular feed specific to CRISPR technology. So here's a science article. I think this is one of the seminal papers for CRISPR, if you're familiar with that concept. And it's available through PubMed. So we basically grab it from PubMed. We parse the metadata layer. And in that, we have the title, the abstract, the authors, affiliations, the keywords that the authors kind of specified in the journal. And the PM ID is the PubMed ID. So taking this data, we do a number of things to it. The first thing we do is apply concept tagging. So instead of just the keywords, we apply our own concepts to the paper based off of what keywords we detect in the title and the abstract, and even the keywords. And this is all controlled through something called a biomedical ontology. And an ontology is a controlled vocabulary that defines these concepts and their relationship to one another. So this is kind of what's controlling what concepts get tagged to each paper. We also have some machine learning algorithms at play here. So author and affiliation disambiguation. This will simultaneously separate cases where we have ambiguous names referring to different individuals, and then also to merge cases of variant names referring to the same individual. So if I see a paper with the name B. Nelson on it, does that refer to Ben Nelson? Does it refer to Bert Nelson? Does it refer to Bort Nelson? So this algorithm is able to separate those authors out. And there are cases where you may have the same author, but they're listed as different names on different papers. So I know even for my own papers as an astronomer, I had like Benjamin E. Nelson, Ben Nelson. And so this algorithm should recognize that those are the same people. So now we have our paper ingested into Meta. That's all good. But now how do we get it into the feed? So as you heard from before, we have concepts that are tagged to each paper, and we have concepts that define each feed. And so we just do simple concept matching. And if it meets all the criteria, then paper can get surfaced in that feed. But then we also apply something called synonym expansion. So if in your feed definition you had a concept like gene editing, well, that's going to be a synonym for that could be gene modification or genetic modification. And so we take those concepts and expand it into their synonyms just to have more possibilities of matching to other papers. And then the predicted impact calculation is a calculation basically predicting the impact this paper is going to have. And the specific calculation for this is something called an eigenfactor. The eigenfactor is normally used to calculate the impact of a journal, but there is like an article level impact factor that we calculate. And this essentially goes into ranking what papers show up at the top of your feed. So something of a higher predicted impact is going to show up at the top of your feed, and then things that are going to have lower impacts sort of drift to the bottom. All right. So here are some other kind of functionalities and just features of Meta. If you don't want to rank by eigenfactor, there is another option to sort by interactions with Meta. So we kind of detect like how you're interacting with Meta, what papers you're clicking on, and we try to best guess based off of those interactions what papers you're interested in. And so you can sort by what we call personalized ranking. And so there's that option. There's the option to sort of save papers to your library. You can discover popular curated feeds. So we have actual PhDs in biomedicine on our team, and they've created feeds that they think are valuable to the broader biomedical community. You can also identify trending papers. So you can see at the very bottom, 243 people are discussing this paper on social media. And this is something, this is, how do I say it? So this is basically powered by another tool called Altmetrics. You can use this for your own astronomy papers if you want to try to surface like what papers are trending on social media. All right. So that's enough about Meta. I think for the remaining time, I wanted to talk a bit about the work that I do in product analytics. So despite the the academic nature of this product, my role and responsibilities are pretty typical of a product analytics data scientist at a startup. And so questions that, a lot of my work sort of revolves around is the question of, are users getting value out of Meta? But before getting to that, I have to define what value looks like, both for the user and from our end, because users don't pay for this product. And so we have to measure value in some other way. And as you saw from before, we have these very long timeframes to achieve these goals. So we have to consider, what do we want to measure right now? And assuming that we have good definitions for this, how do we measure it with the data that we have? All right. So I think it would be useful to talk a little bit about metrics. I think a lot about metrics, and during my time at CZI, I've had a lot of conversations about metrics with engineering and product management teams. And I think most data scientist interviews will cover the concept of metrics in some form or another. So I think it would just be useful to talk about. For machine learning problems, if you go to an interview that's very machine learning focused, you may be asked questions about accuracy, precision, and recall, maybe F1 scores. And these are all well-defined concepts, and it's good to know what their applications are. But in product analytics, there really isn't a correct answer for what the right metric is at any given time. And if there is, it depends on a lot of different things, like what your product area is, what stage of the product life cycle you're in. So there's a number of things you could choose, but I think there are like a good set of principles that you can adhere to in order to make a decision on what metric you want to monitor. So what makes a good metric? Here's a list of ideas that I drew upon from a book called Lean Analytics. This may be a book that you've heard of before or maybe recommended. It was recommended to me by Jonathan Whitmore, who some of you may know is an astronomer turned data scientist. And it really helped sort of pivot my thinking when transitioning into data science. So I highly recommend picking up this book. And if you really don't want to, there's this 45-minute video at the bottom of this slide by one of the authors that summarizes what the book is all about. But this is a good book to have just for preparing for interviews and kind of thinking about metrics at your own company. So, what are these principles? A good metric is usually comparative. You can compare it to different time periods or cohorts. You can compare different users or objects to different performance benchmarks. The whole idea here is that once you get a value for what this metric is, if you should be able to compare it to something to whether, so you can actually understand whether or not you are doing a good job. This metric that you're monitoring should be understandable. You're going to be usually talking about this metric with lots of different teams. And if you can remember it and discuss it, then it's easier to turn a change in data into a change in company culture, right? So if you and your team can easily talk about it and you understand how it's changing, then you can change how your company handles and deals with data. It's probably a ratio. Ratios are just easier to act on. They're inherently comparative. They're good for looking at opposing effects. But I think the most important thing about good metric design is that it changes the way you behave. It's what's called actionable. So if you see whatever this metric that you have is change, is it actually going to change your behavior, right? Will I do something differently based off of changes in this metric? Yeah, so here's just another sort of breakdown on choosing the right metric. I think I'll just kind of skip this portion, but I think the one thing to point out here is that there is sort of a counterpart to an actionable metric called a vanity metric. These are just metrics that make you feel good. You don't really act on them. This could just be the total number of signups on your platform. Like, yeah, it's great, you have 1 million total signups, but how do you act on that? It's a vanity metric. So you go for ones that are actionable. So let's actually get into an example of metrics and meta. So this is actually, like, I'm kind of paraphrasing here. This is a conversation I had with PMs at CZI about trying to measure engagement with meta. And this is kind of how the conversation went. So the first thing we were trying to think about was, well, how often do we expect users to be active on this platform? Should we expect daily use, weekly use, or monthly use? I think it would be nice to see people using this platform daily. Monthly is going to be a bit too long. But weekly is about the right cadence for this product, right? Because these are academics. They may have a weekly journal club where they present on papers. There just may be some days where they're too bogged down with research that they don't want to read any papers. And so weekly use is sort of the cadence that we're looking for. So given weekly use, how do we measure engagement? Should we measure it by the average time that users spend on Meta this week? If they spend 15 minutes or 20 minutes, is that a good measure? Well, not really, because it doesn't really tell us why they're sticking around, right? They could be lost on the app. They could be on help pages. So just spending time on the app isn't really the thing you want to measure here. Well, so what do we want them to be doing? Ideally, we'd like to see them clicking on our content, right? We want to see them clicking on papers. So how about just the number of paper clicks this week? Well, it's getting closer, but still not good, because seeing more or fewer clicks could just be due to more or fewer users being on the platform this week. All right, so let's normalize to the number of users this week. So how about the number of paper clicks per weekly active user? We're getting a little bit better, but this isn't robust to super users, right? So we actually do see on the platform users that are clicking on hundreds of papers in their session. And that skews this, right? Because this is essentially an average. And so if we just have one user in a particular week that's just clicking on hundreds of papers, then that's going to skew our statistics. So then how about the percent of weekly active users who are clicking on at least one paper this week? And this is what we've chosen, or this is close to what we're actually using, because it tells us what fraction of users this week are finding relevant content on our platform. Now, there's reasons why this may not, be perfect, but what's important here is that it's actionable. When we launch a new feature, we can see this number increase or decrease. We can measure this every day, so we can actually monitor this over time. We don't have to wait years to be able to, measure this impact. So it's actionable. And I'll briefly go over these last couple slides, but getting accurate event counts is surprisingly difficult. You might see figures like this in sort of data science blogs or AI blogs about sort of a hierarchy of needs. And essentially what this is saying, at the top of the pyramid, you've got like your machine learning, your A/B testing, your multi-arm bandits, like the fun stuff you want to do in data science. But you really can't get to that point unless you have a solid foundation of sort of good data, right? So at the very bottom of the pyramid, you want to be able to collect all your data, to be able to log everything that people are doing on your application. And this is often in collaboration with your engineering team. The very next level is sort of cleaning it up. So getting it to a state where you can actually start to analyze it. The third layer is defining and tracking. So setting a framework so that you can measure success, or, one example could be like a conversion funnel where people start off, they sign up for the platform, and then they eventually get to a state that provides value. But yeah, so the whole point of this chart is to basically show you that you really can't do the fun stuff, the machine learning and whatnot, until you have a good solid base of data. So if you can't do simple counts on your user data, you really can't do the fun stuff. Okay, so just to briefly summarize, the Chan Zuckerberg Initiative Science Initiative is tackling a wide variety of problems in the biomedical sciences. There are a number of efforts in imaging and open science that I feel like could be of interest to astronomers, and you can check out our website for open roles right now. We are currently hiring software engineers, and definitely be on the lookout for data science roles as well. Meta is a research discovery tool using machine learning to recommend papers and preprints. And my role as a data scientist is really in product analytics and defining and measuring user value from our platform. And yeah, I would definitely study up on good metric design if you're thinking about a role in data science. And the Lean Analytics series by Kroll and Yaskovitz is definitely a great place to start. And with that, I'll take any questions. Thanks.
Thank you, Ben. I think we just, well, I'd say looks like we have one question, so we can go ahead and address that before we move on to Julia's talk. And if you have other questions, feel free to ask in Slack. Yeah, I guess I'll take the question here. Lauren asks, it feels rare to see open science in a field that can be very profit driven. How does the initiative plan to push other institutes to be more open? And have you seen more open science in the biomedical field due to your initiative goals?
Ooh, okay, that's a good question. Let me sit on that one for a second. But I won't take too long because I realize we got the next talk coming up. So how does the initiative plan to push other institutes to be more open? So I don't think the push, yeah, there's a lot of that. So I don't think the push is necessarily on institutes to be more open, at least from like the meta side of things. There can be, I guess, initiatives to push for open science, maybe from like the other sci-tech teams. We encourage and there are policies in place to allow certain like biomedical articles to be open access after a period of time. So I think, that's like a step in the right direction. And have we seen more open science due to initiatives goals? I've only been here for about 6 months, so I actually can't tell you like the timeline at which I've seen open science initiatives happen and the pace of which that's happened at CZI. Hopefully I can provide an update 6 months from now, but yeah, I don't think I can speak to that.
Thank you. I see a couple more questions coming in. Ben, if you wouldn't mind answering those either in the Zoom chat or on the Slack channel, that'd be appreciated.
Yeah,
but we need, I'd like to move on now to Julia. Her talk's entitled Data Visualization for Real World Machine Learning. I don't think I have to go on about how important visualizations are, so very much looking forward to this talk. Julia, are you all set?
I think so. Does that look good?
Yeah, looks great.
Awesome. Great. Well, thank you so much for having me. I'm really excited to be here today. Yeah, my name is Julia Silge, and I, like I think all our other speakers, I'm an ex-astronomer. I'm now a data scientist, and my title is actually data scientist and software engineer at our studio. And I am excited to be talking today about data visualization and how it is used as part of the machine learning process. We often talk about data visualization as one of these communication tools that we have when we are sharing outward, when we are taking what it is that we have built or what it is that we're wanting to say, and we're communicating outward. But what I'm going to be focusing on today is how we use data visualization to make better modeling choices, and how plotting, making charts, data visualization is a tool of system designers and operators themselves. So, you know, if like in astronomy and machine learning, in any way that when we are working with data, data visualization is you know, hugely important tool for anybody who is working with data, not just people who are building models or machine learning systems. And a lot of what we're going to talk about today is true because data visualization is so effective at surfacing information to human beings through these visual channels. And these visual ways of thinking or these visual ways of perceiving information form how we think about the work that we're doing, how we understand the problems that we're solving and the models that we're building, and what I want us to focus on today, how we decide. How it is that we decide what we're doing. And I want to focus on data visualization as a support or an aid for decision making, because building models or machine learning systems is you know, one piece of typically what a data scientist does in their job. And it is this complicated, involved task. And I want to frame it explicitly a little bit the way that Tamara Munzer, a big, an important researcher in the data visualization field, as she does here. So we use you know, our computer code-based systems to represent data sets, to represent models for a specific purpose when we're building our machine learning systems, our models, and thought of, you know, broadly, that purpose is so that we, as the data science practitioners, the machine learning practitioners, are more effective. We can carry out that task more effectively, that task of building a model, that task of building a machine learning model. So when it comes to models and machine learning, more effective can be thought of in kind of like a multi-pronged way. Like it can have a couple of different meanings. It can mean, you know, more accurate. It can mean more practically appropriate. And it can mean more fair. And we're going to talk about a couple different of those today in this talk. So you know, my academic background is physics and astronomy. I have a little bit of one of these winding career paths that I think a lot of us do who are talking up here today. But eventually, my winding career path landed me working on open source full time. So I work for RStudio, who is a public benefit corporation where about half of the employees work on open source and about half of the employees work on professional products for data scientists. And I work on an open source framework in R for modeling and machine learning that's called Tidy Models. And a lot of the examples and things that I'll be showing you today use Tidy Models code. Some of the specific goals of the Tidy Models project are to provide a consistent, flexible framework for real-world modeling practitioners, those who are just starting out with machine learning, to those who are very experienced, to harmonize the heterogeneous interfaces that exist within R for modeling, and to encourage good statistical practice. I'm glad to get to show you a little bit of what I work on, but a lot of what we're going to talk about today is not specific to R, is not specific to Tidy Models. It's a bit more high level and focuses on these like how do we use data visualization? How do real world folks use data visualization when we're building models? So I want to start out by asking this question. When do machine learning practitioners build data visualization? So asking this kind of question requires us to think about the process of model building itself and to build a mental model of model building. So I'd like to put this out there as a schematic of what happens during a typical process of a modeling practitioner getting from the point of first seeing some data to having a working model. So the modeling process starts over here with this step of exploratory data analysis, EDA. This is a systematic, iterative process of exploring data to see what's there. After this comes feature engineering. So this is the task of transforming our original variables that we have in whatever format they came to us to some more useful feature that will be more useful to the model that we want to build. After this comes model fitting and tuning. Notice that I represented this here with lots of little lines, and that's because when we're using best practices, typically we do this with resampled data sets. So we fit and tune and fit and tune and fit and tune many times to resampled versions of the data set. Also notice that we typically are not doing this one time with one model, but rather with multiple models, because for any given data set, we typically do not know ahead of time what kind of model will work best for that particular data set. Typically, we have to try different models for any given data set to understand which one is going to work better. At this step, next we have, after we have the models that have been fit and or tuned using resampled data sets, we typically are at this stage of model evaluation, where we're measuring how well all those models performed using some metric that is appropriate to that specific kind of model that we had and problem. Notice, though, that we're not done, because actually this whole process is iterative, that we go back, we say, oh, given what we just learned about how the different models perform, we can go back and we can go back to the EDA process and look and see, oh, why did these examples turn out badly and these well? I need to invest some more time in feature engineering to account for why that happened. Let me go back to those two models that performed best and fit and tune them again with my new features, and then evaluate again. This whole process tends to be one that is iterative. Also notice that this process ends with some goal or output. This could be communicating the results, if this is a model that its goal is understanding, like or it could be deploying the model to a production system if the goal of the model is just purely prediction. That I've represented here with a skinny bar there, but really picture that as transitioning to a whole other set of tasks. In this talk, we're going to focus and keep our scope on the iterative process of building the model itself, everything kind of before that bar. So machine learning practitioners can, of course, make plots at any point that during this whole process that they want to, but I want to make the argument that there are two phases of the model process where practitioners use data visualization the most. The first is EDA. And I said before, the EDA is this iterative phase of investigation, question generation and refinement and exploring. And so this is a phase that some people might say, wait a minute, that's not really part of machine learning. That's before machine learning, that's outside of it, or not part of it. But we're going to see how the investigations and understanding that is gained during EDA have a huge impact on models. The second phase, where practitioners make a lot of plots, is during model evaluation. And this is a part of the modeling process where a practitioner has trained probably multiple models and then is assessing, measuring, and comparing how well they performed. So if you were able to, come and like look over the shoulder of someone building a model, these two parts of the process are where you would see someone creating the most plots, I'm arguing. And in my opinion, like using visualization in a really lavish way at these phases is a sign of a healthy model building process. And the reason why is that these two phases of the machine learning process are the points of most important human decisions. These are decisions where validation of them can be difficult. You might, hear people say things like there's art, not science involved. And that's because they're full of trade-offs. And visualization is being used as an aid or support to make those trade-offs and to carry out this task more effectively, like Tamara Munzer said in that quote that we had at the beginning of this talk. So let's dig a little deeper into this and look at some examples of what I mean when I make this argument. So let's start with EDA. And let's ask this question: why are these plots built? So at a high level, these plots during this process are built to understand the data. So when a practitioner starts out on a modeling project, this is one of the first substantive tasks being faced. So the reason we as practitioners need to have this understanding of the data is because there's about to be a whole bunch of decisions to be made when building the model. So these data visualizations let practitioners ask and then refine specific questions related to the modeling goals, like what kind of model is appropriate. This then feeds into the feature engineering phase and like what kind of data pre-processing is needed. And all these kinds of questions are ones that machine learning practitioners ask and refine and answer by making plots during the EDA process. Let's finally look at some. I don't think I've shown many plots yet here. So some of these plots take the form of very familiar statistical graphics, like this scatter plot. So this plot uses a data set called the Palmer penguins. So it's penguins that are observed in Antarctica near Palmer Station. And it maps each observation of a penguin to a point on the plot with aesthetics of the plot, like positions, X and Y, and size and color, representing things that have been measured about these penguins. So exploratory graphics like this are important for machine learning practitioners because they help us understand the type and amount of data we have, and they visually highlight the relationships in the data that we can use in feature engineering our models. So if we wanted to build a classification model to predict the species of the penguins, or maybe the sex of the penguins, based on the other measurements that we have of them, the relationships that we discover in this kind of graph inform the steps that we can take moving forward. Plots for EDA don't always look like the super classic statistical graphics. So in some ways, this plot also is just a scatter plot, but the mapping is different. What's being mapped is different. This is in fact a map. So it's showing a data set of trees in San Francisco. So that big empty area is Golden Gate Park, and the other empty areas are smaller parks. And the color is who is in charge of maintaining each tree. Is it the Department of Public Works, or is it somewhere else? So if our goal is to train a model to predict, say, the maintainer of each tree, a plot like this is hugely impactful for the person who's in charge of it. So like right away, we know the trees in the parks are not in the data set. We might, for example, like see, immediately be able to see something like whether we would want to invest much time in trying a linear model versus going more quickly to a model that can learn interactions well, like a tree-based model. We would be able to learn from a plot like this what predictors we would expect to be important, and we get from this just from using visualization as a tool in the EDA process. So machine learning practitioners use visualization during EDA to make many different kinds of plots. So it's important that the tools we use for visualization during this phase facilitate fluent iteration through lots and lots of different kinds of graphs. So I have decades of experience with various different kinds of scientific plotting tools. And in my opinion, learning about internalizing the concept of the grammar of graphics is a huge step in this kind of being able to be fluent with this kind of fast, efficient iteration. And adopting a system that applies this grammar gets you just a huge step forward in this efficiency, in this task of asking, refining, and answering questions to get ready to train models. So ggplot2 in R is probably the best known system that implements the grammar of graphics. And the plots that I'm showing here have been made with that system. But if you're a Python user, visualization systems that implement the grammar of graphics include Altair and Plotly. So we've talked so far about maybe like the kind of models you might want to make, but EDA also informed decisions about what kind of models to train. What kind of models, and then also decisions made in feature engineering. So in tidy models, we capture data pre-processing and feature engineering and the concept of a pre-processing recipe that has steps. So you define the steps and prepare them using training data, and then you can apply that to any data set like testing data or new data. So the reason why is that you can protect against data leakage for pre-processing the way you typically would with a model. But the specific feature engineering steps are typically chosen because of what we learn during EDA. So let's look at another example data set. So this is the data set of houses in Ames, Iowa. So we have a lot of information about the house characteristics, like how big they are, where they're located, and their last selling price. So this plot shows the sale price on the y-axis and the latitude on the x-axis. So there's a big hole there, and that's where Iowa State University is. And then there's some unique and complex structure and price as you move across the city. So we have some options if we wanted to try to model that structure, to be able to say like, hey, how expensive is a house depending on where it is in the city? One option we have is to build new features, like you do feature engineering, and we can use splines to build new features for modeling, but we have to decide how many spline terms to use. So 2 doesn't look like it captures the real structure very well. 5 looks better. I would believe 10. 20 seems okay, but I'm starting to feel a little skeptical. At 50, I no longer believe this. And at 100, this is just silly. So what's great about data visualization during the process of EDA is that we as machine learning practitioners can see and absorb this and then use it to make decisions. And if you use tidy models, these decisions may end up looking like this, with a feature engineering recipe defined with steps that transform and prepare our data to get it ready for modeling, whether that's dealing with factor levels or creating indicator or dummy variables or setting those 10 spline terms. So whether it's for engineering new features, choosing an appropriate model, or understanding data quality, data visualization during EDA has a huge impact on what model practitioners do later on. So in a lot of ways, it's a foundation on which the rest of the model process is built. So it is often possible to estimate or tune the best answer or value or option for some of these choices that we've talked about using empirical methods. Like we can tune the number of spline terms based on our data, but it is nearly impossible to remove entirely the element of human judgment from these choices. Or at least it's a bad idea. So machine learning algorithms are astounding. They're incredibly capable of learning patterns from large amounts of data. So vigorous adoption of exploratory data analysis as part of the machine learning process is one safeguard that we have against ending up in a situation where you have to ask yourself whether it was a good idea to just deep fry your data. So let's move now to model evaluation. the phase where we have trained and possibly tuned models. So we have predictions to compare true values to and can assess how our models are performing. And let's again ask this question, why are these models built? So at a very high level, plots, sorry, why are these plots built? So at a very high level, these plots are built to understand the models. So at this point, we are assessing model performance. So at this point, we as modeling practitioners have to reckon with questions about success and failure and ask, did this model work? We also can interrogate subgroups, and this is typically where discussions of model fairness come in. So a lot of the current work on machine learning bias and fairness focuses on how models perform differently for different subgroups, perhaps for different protected, like legally protected classes that may not have been included directly in the model as predictors, but we can still see differences in the output because maybe certain predictors were proxies for those classes. Model evaluation is also concerned with understanding with why a model is making the predictions it does. And so this is like model explainability. And so for all these questions, practitioners heavily use data visualization for a lot of the same reasons. It's used during EDA, which is, again, a lot like the same reason anyone ever uses visualization, to show relationships clearly that would be difficult to see otherwise. So let's look at a couple of examples of these. One of the reasons why model evaluation plots are interesting is that a lot of these plots for model evaluation involve graphical norms or idioms. So this plot shows how two model evaluation metrics, RMSE and R squared, change for a lasso regression model, a regularized model. Like how regularized is it? Like just a little bit or a lot? So someone who is familiar with these kinds of models, you know, if some of you have used them before, you probably looked at that and you were like, yep, okay, I know what that is. And it's because you can quickly recognize whether or not it worked, whether it's a model that needed a lot of regularization or a little bit. And looking at the R squared, you could say how well, or in the case of this model, how not well, the model fit the data. So it's like a shorthand or an idiom that packs a lot of information for a familiar audience. This a lot is similar. This is a receiver operator characteristic curve, an ROC curve. It's 10 of them actually. This is for a model trained on that Palmer penguin data that we discussed at the beginning. And it's a visual representation of how well a binary classification model is doing. So the more up in the left-hand corner those curves are, the better the model is doing. The axes have the true positive rate and the false positive rate on them. And ideally, we want both of those to be great. So this is another example of a model evaluation visual idiom that's familiar to modeling practitioners, and it can be used to compare models, assess a model, and so forth. So these kinds of visual idioms are a great fit for automatic plotting methods. So when we talked about EDA, I said, oh, we need a really flexible plotting framework, and you need to learn how to be able to really fluently create any plot really quickly, and you need to know about the grammar of graphics and be able to create anything you want in a really flexible way. So a lot of model evaluation plots are the same every single time you make them, and a machine learning practitioner can be better served using shortcuts built by tool builders like, say, me and my teammates, because it can be a hassle to copy and paste the same code for an ROC curve every single time. However, it is important to keep in mind that not all plots for model evaluation are these kinds of standard idioms. So this is also a model evaluation plot for a model that is predicting the class of a volcano. And each hexagon there shows the percent of volcanoes that have been classified correctly. So while knowing about automatic plotting methods in your, visualization system of choice are important, still having that fluency is very important. I see that we're kind of at the at time, so I am going to just kind of skip through these slides on model explainability and get to talking about how through this whole exploration of data visualization, I've been talking about data visualization's function as a tool used by system designers and operators for themselves to make better modeling choices. So these are plots made by practitioners for practitioners. So often when we talk about data visualization, we center it as a communication tool, and it absolutely 100% is. But we also can think about how data visualization is actually a tool used by system designers to understand a system more fully, to build a better system. So parts of the machine learning community recently have been exploring what are called participatory approaches to machine learning, where system designers partner with the people impacted by the system, like the users of the system, in shaping and designing the system. And I think that's going to be interesting to watch, because it may change the answer to this question, like who are these plots for, especially these very kind of specialized plots that require some knowledge to understand them. What I don't think it will change is the main purpose of any given data visualization. Some plots are created to help us understand the data that we start with, the input for the models that we create. So investing in data visualization to understand the data is like laying a strong foundation. Some plots are created to help us understand the models that we create, the output. So careful visualization practices in model evaluation sets us up for success in models that are as accurate, as appropriate, and as reliable as possible. And with that, I'll say thank you so much. I want to be sure to thank my teammates on the Tidy Models team, as well as the folks who organized the Tidy Tuesday project. Tidy Tuesday is a weekly social data science project, and most of the data sets that I shared today are from that. So I will say thank you so much.
Thank you, Julia. Yeah, there's a lot of questions in the chat, both on, well, in the Zoom chat here about specific packages to use. See a lot of good answers there. Yeah, I think we need to be mindful of the time. We have a plenary lecture in 10 minutes. So
yeah, I can try. I think I can try to answer any questions I can, and we can maybe move on. So because I know this session went a little over.
That's okay. Yeah, thank you for that. Yeah, I guess I'll share my screen just to get something to set the stage here. We have 10 minutes, so we can at least think of this as setting the stage. Looking at our schedule here, we have about 10 minutes here before the plenary lecture, so we can set up the problem. And then when we return, we'll be continuing this discussion for 15 minutes before we go on to our third and final talk session. So as some people pointed out in the chat, this first open discussion is about the most and least useful things to do while in academia for success in the job market. I would say easily, as a professional data scientist, one of the most types of asked questions I get in the professional field on how to do that. So Jeff, do you want to hop in at all here?
Sure. I mean, I'll give my 2 cents, and then we can pass it around to the other speakers.
Please open it up.
Yeah. Yeah, I mean, I think some very useful things are coding in Python or R. Those are pretty typical industry standard. I fully admit I used IDL and IRAF for my entire astronomy career. And while that got me a PhD and a postdoc, it did not help me get a data science job. So there's that. Sort of under that umbrella is just using industry standard tools. So we just heard from Julia about some, ways to build models and train models and test models and make plots, using those kinds of tools, writing code and putting it in a GitHub repository, even if it's very simple code. It doesn't have to be a giant fancy app, but some piece of code that you have for your research, put it in GitHub, understand how Git works, how a repository works, how version control works. Those kinds of sort of industry standards.
Yeah, this is about
are key.
Yeah, they're talking about astronomers that go to data science.
So that's one thing. Anybody else want to take a most or least useful thing to get things going here?
I would say, even if you don't use the tools, knowing at a high level what those tools are and what they do is really useful in interviews. So even if you've never deployed a Docker image or have never used, say, I don't know, Google Cloud or Microsoft Azure, knowing the differences between Google Cloud and AWS and some of the older tools on AWS versus some of the newer offerings does tell someone, okay, this person, might not be an expert, but knows the lay of the land, and that can be a big plus in some, especially for junior roles. On that front, I would say like networking is hugely beneficial. Most people I know got jobs or connections or heard about a job through something. It's very, very rare. I would say probably 40% or less of the people I know in data science who transitioned from academia did it by cold calling or sending LinkedIn applications. So having a network definitely helps. We can talk about all the privileged biases that introduces into the process. But I would say that, and also applying to jobs, even if you're not able to take something, I think there are some places like where I would say draw a line and say, okay, don't annoy too many hiring managers by spuriously applying to jobs. But I would say getting a practice into what the interview process, the hiring process looks like is very beneficial. So unlike an academic job cycle, where there's a very distinct period of, say, like in the fall, where everyone is applying to postdoc and faculty positions. In industry, it's year round, and jobs get filled. It can fill up in 2 weeks or 2 months, but that's the rough time scale. So, you can't look at a job and say, "Oh, this is a great job," but it's not the right time for me. Right? It's like that same company is probably going to hire again in 8 months if they're rapidly growing. So it's like, it's not like you're burning bridges or so it goes both ways. But I think there are lots of opportunities. Try it out. You'll get to see what the interview questions are like. You'll get practice answering interview questions. You'll get practice into the kinds of data challenges and homework and coding exercises they have you do. You'll get to see differences in different companies and teams' approaches to supporting people remotely, to different industries out there, different kinds of focuses and positions. So you get a lay of the land that way. And I don't think there's a substitute for that. I'll stop talking now.
I'm going to second basically everything that's been said already. And I'm going to add 2 things. One thing on the technical side, yes, Python or R or maybe both is great, and Git as a tool for version control, but also some kind of understanding of databases and data queries, because you need to be able to get data from somewhere. So even just a basic knowledge of SQL goes a long way. If you have none, if you've never interacted with a database, set up MySQL on your home computer and play around, because one of the things that you'll have to do in any data-centric job is actually be able to pull data in. So SQL is a pretty mainstream tool for that. There are also other kinds of more document structured type databases, but even just a little bit of understanding about how people pull data out of tables and how people join data across tables is a really valuable basic technical skill to have some familiarity with. The other thing that I would really recommend in preparation for job applications and interviews is to practice talking about the work that you've already done as a scientist as though it's a data science project. So figure out how to highlight the things that you've done that are going to be interesting and communicable to a non-astronomer, so that you can explain what you've done, but also think about ways you can highlight how that work used computer modeling of data, and how you could sort of draw connections between whatever your existing experience is and frame it basically as data science. Because the truth is, most astronomers are data scientists, right? When I introduce myself, I am a data scientist. I've been a data scientist for a couple of decades now. I started out as a data scientist who studied galaxies. Then I was a data scientist who studied people, right? And now I'm, doing a bunch of different things. So just practicing with a friend or with a colleague in industry how to talk about the work that you've already done, but frame it in a way that screams data science rather than astronomer, is very useful.
One other skill that I don't think has been mentioned is being able to code with other people using Git or some other version control, and having some sense of best practices of how you develop code when it's not just a script that's running on your own personal computer, but something that is software that other people are going to be using. And start doing that during your PhD and implementing those practices in your PhD group if they're not already implemented, because there's a very different way that you would approach coding if you're working on a team of 10 to 100 people versus yourself.
Yeah, I do want to, well, I totally agree, Jess. I feel like a concern I've heard from a lot of academic astronomers is that they don't feel that they're good enough coders to be data scientists in industry. And I think that's not true at all. Like,
you should see the data scientists in industry. Oh my God.
Right. I think most astronomers that I talk to, and I certainly felt this way too, don't write good code. That maybe that's lazy, maybe that's you don't know some of the, the best practices, but we can learn things very quickly. And with some modicum of effort, like Jess was saying, and some practice, you can develop these skills and develop them well, and certainly well enough to get a job in industry. So I want to, that is that sort of fine line to walk there. We're coming up on time that we should break for the plenary. We'll continue this after the plenary at 4:15 or so Eastern time. Noelle did put in a nice question for us to think about how to, given that we can program and use Python to solve problems related to their work, how can they kind of show that off or put together a portfolio of data science projects? So we will think about that in during the plenary, and then we will come back in an hour and continue where we left off. Thanks, everybody. Perfect. Thank you, Sydney, our awesome tech support person. And let's continue discussing most and least useful things to do while in academia for success in the job market. So one of the questions that we got before the break, and that there was some discussion in the Slack channel, was around data science projects or data projects or portfolio that you can build up while in academia to show off these skills that are valuable in the tech industry. And there was a lot of advice. There was a few examples shown in some of those threads. One thing that I always like to mention to people is, it's a way at some level for, someone to get to know you, but, to pick a topic you're interested in that's not specifically astronomy or related to your research. But more than that, and I think this was mentioned in Slack, a big skill that we look for in data scientists is the ability to communicate. Especially with non-technical audiences, right? I think astronomers tend to be very good at this. We give, lots of education and engagement talks about astronomy topics. You're going to work with other engineers and data scientists, and that's great to talk technical to them. But you're also going to work with executives and salespeople and people without statistics training. And so the ability to be able to talk about a complex or technical topic to those groups is important. And a way to show that off is if you have, a project or a fun, portfolio, website, app, whatever, about a non-technical subject or a subject that's different than your astrophysics research.
Related to that, I would think carefully about what your strengths and weaknesses are, both as an academic communicator and whatever industry or space that you're curious about moving into. So I knew very early that probably explaining things and communicating and distilling big points into, or very granular points into big ones, was something that I was able to do as an astronomer. And I tried to build a career off of that in data science. So, and on the other hand, I knew that I wasn't the strongest coder, that I had a lot of studying to do about the different tools that people used in industry, the different way people preferred to communicate about problems, the jargon that comes in the space. So I knew what I could leverage, and I knew the things that I had to work on. So I would definitely do a careful introspection of that and then get feedback on those points.
Other folks want to chime in or reiterate some of the stuff that was mentioned in the Slack channel?
One thing that's great about doing your own project that's that's a little more mainstream and not necessarily related to astronomy is that it also helps you start explore some of the things that you enjoy. And one of the big things you're going to want to do in an interview is communicate your enthusiasm for data and data science and what you do. So what you really want is an example project that you can talk about that will be comprehensible to a non-expert listener, but that also where you're going to be animated talking about it, and you're going to get to show why you are passionate about what you're doing. And that's a huge thing employers want to see, is they want to know, they don't want to hire people who are there to collect a paycheck and go through the motions. They want to hire people who are going to get genuinely passionate about what they're working on and genuinely passionate about the trajectory of the organization that they're a part of. And picking a project that's interesting to you, maybe that's your thesis research, but maybe it's not. Picking a project that you care about and are interested in, and then doing a little bit of exploratory work also gives you an opportunity to show that excitement and that passion. And I think for some people, some people who are leaving astronomy are leaving in part because they have burned through their passion for a particular topic. So if that's you and you're like, great, I'm glad I did it for a decade, I never want to think about a galaxy again, this can be an opportunity to play around with something new and different that you get excited about as well. And so then you can not only convey your deep knowledge and ability to explore something really deeply that you did as a PhD student, because that's what a PhD is, right? It's going super deep, but you can also communicate that enthusiasm for exploring new things, learning new things. And it's still early enough that you have that sort of gleam of passion in your eye when you talk about it.
I 100% agree with that. I would say, as someone that picked a really niche kind of a showcase project when moving into data science, maybe not pick a project that is super niche. Like things like if you want to play with COVID data, if you want to play with stock market data, people know what that is and can relate to that. I did a pretty in-depth project on baseball statistics, and I had to work really hard to make sure that it was understandable at a high level by people that didn't know what baseball was.
Also, part of what the opportunity is to convey with your project is like, are you a fun person to have as a colleague? Are you somebody that I want to like have lunch with? And so if it's a project that I, as the interviewer, also find relatable or interesting, then I see myself in you and I'm more likely to think favorably of you, fair or not fair. I'd also just warn that there is a class of people who interview for data science jobs as kind of a backup when they aren't sure if they're going to get their postdoc or academic position that they want. And that kind of comes through in both like a arrogance in the interview, kind of making it seem like, oh, well, you should be lucky to have me and I'll choose to, go down this path of data science as my second choice. But also then just seeming to not really be passionate or interested about the company. And so if you pick a project that shows some other interest and isn't just kind of a direct branch to your thesis, it can hedge against that a little bit to show like, hey, I have been thinking about other paths. This isn't just a backup plan for me. I have put some energy into developing something so that I have this portfolio. And it can just help interviewers not try to like classify you fair or not as this type of candidate who is only applying to this job as a backup plan or a second choice.
I think related to that, every job you apply for, do some research on the company and the role and the industry. I've had a lot of interviews as a hiring manager where they seem qualified on paper, But when the interview or the screening call gets to, well, what questions do you have about, for me about the company or the team? And they've got nothing. Well, there are other qualified people I'm going to, it's like if you didn't take the effort to Google the company and don't have any questions for me, that's a huge red flag. So definitely like, it's not, yeah, I'll leave it at that.
So one thing that I think gets to some of the earlier questions about, and a little bit of the overall discussion topic of sort of skills that you can try to bulk up or things that you can do in academia that would help you get a career or help you in the job market in industry and in the tech industry. We talked a little bit about, these data science projects or portfolio, stuff like that. As far as the skill building itself, we talked a little bit about, coding tools and using industry tools. But one thing I do want to point out also is that, and this gets a little bit to what I think a couple of people mentioned as far as interest in the type of work or the type of company, is you don't have to be an expert in everything, right? Like in academia, in astronomy, I knew a hell of a lot about type 1a supernova spectra. I would say probably top 10 in the world, something like that, right? That's outrageous. Whereas like, I know nothing about and never knew anything about, infrared photometry of brown dwarfs, right? Like we all specialize. And I think that's, that's definitely true of data science positions as well. Maybe not as extreme, but, I, as a data scientist, I'm very good at data analytics. What we were talking about earlier with metric definition, that's a lot of what I work on. I've never done natural language processing. I know sort of the buzzwords and I know kind of how they work, but I would fail miserably in a position where I had to do a lot of that kind of modeling, whereas I do quite well in other types. So, you kind of want to know a little bit about the basics of everything, right? The 101 level of machine learning or these tools, but find a piece of it that you like or that you really dive deep into and you can put together a project that uses, a specific model. Don't have to use every single model for your one project.
You're kind of alluding to like the T-shaped skill set, right? Like you want to be very general in a lot of areas, but then have really deep knowledge in one thing. And as a data scientist, like as you grow in your career, you might get like another depth spike and you would be pie-shaped rather than T-shaped. So yeah.
Other questions from the crowd? Or we've talked about a lot of useful things. Most useful things. A least useful thing that did come up in the Slack channel, or somewhat useless, was some of these online courses certificates. So if we want to talk about that briefly here to reiterate some of the Slack conversation, online courses can be very useful. You learn a lot of stuff. That's great. If I see a resume that somebody has, 10 different certificates from Coursera, I ignore it completely.
Yeah, but you don't ignore the skills section, and if you list those things as skills, then that's something you can have a conversation about. And really, it's not that those are bad courses to take. It's just that they're not necessarily indicative, a good signal that you actually know those skills. And so, whether you learn those skills from that course or from somewhere else doesn't really matter. Learn the best way you can, as long as you can demonstrate that.
I think online courses are great. I mean, when I started out with my transition, I took a bunch of them on Coursera. I'm actually taking a course in deep learning and PyTorch on Udemy right now and loving it because it's a place I wanted to acquire some additional skills. So it's like the lifelong learning thing is a huge part of it. But particularly if you are not a Python programmer or an R programmer, right? If you're like an IDL programmer, taking online courses and doing projects in Python or doing them in some mainstream language, super helpful. You're doing it to actually build the skills, not to have a certificate on your resume. So yeah, I agree that the certificates themselves don't matter. You don't need to spend money or a lot of time collecting them, but the courses, taking courses for things that you actually want and need to learn is super valuable.
I popped over to Slack and there's a couple questions there. So the first Slack question I saw was, what are characteristics of a candidate that you're going to reject or not hire?
I don't think
Taka sort of mentioned one where, like, if you didn't do your homework, you didn't look into what the company does or have, show genuine interest in what the company does. I think that's, if you get to that point of the interview process.
Yeah, I think that there's rejecting because a candidate just doesn't fit the skill set, and that comes out in the interview. But then there's also rejecting because the candidate does something that makes it seem like they wouldn't be a good colleague or a good fit for the company culture. And so, one thing I said in this Slack thread was, it's great if you've taken a Coursera course in deep learning, but if you put, expert in deep learning on your skills section, and then I start asking you about deep learning and it's clear that you don't know anything about deep learning, then that would be worse than if you would just not put it there at all. And we have rejected candidates who we would have accepted because it seemed like they fabricated or embellished their resumes. And so it's important to, come across in a ethical and, fair way when conducting interviews.
I think it's hugely valuable in general. Even, yes, be ethical and honest, but even beyond that, to be able to know what you know and know what you don't know and be open about that. And it's much, much stronger to come in and be like, yeah, these are the things I know about. I know a lot about that. I have other things to say, I've dabbled a little bit in this. I don't know very much. And other things are like, I've never done any of that at all. And if you, be confident of what you know, because you know things. And the fact that you don't know everything is inevitable. Nobody knows everything. So being able to be honest and own the things that you don't know and express interest in learning about them if you are genuinely interested in them, it's not actually weak to say, yeah, that's not a thing I've worked with. I don't know that. Often then if you can follow it on saying, the closest thing I have done is this, and draw some analogy between whatever skill they're asking for and something you've done that's somewhat similar, shows interest and an ability to kind of connect the dots. But you should be able to comfortably own the fact that you don't know everything, because people, first of all, nobody knows everything, and the people who think they do are a nightmare.
Yeah, I second or third this. And even the data science colleagues that I work with, they're not astronomers, but they value sort of the honesty and, being able to show that you don't know everything and be able to say what your weaknesses are. And I think I'd rather have someone on the team that hits half the qualifications, but seems like I could really work with this person and they'd be willing to learn to pick up on the other ones, than someone who hit all the marks and they seem like they would be a nightmare to work with. And I think that goes for how a lot of people feel in industry.
On a sort of somewhat a tangentially related thing, often job recs will list a set of requirements and a set of nice to haves. Those tend to be very complete. And one thing that frequently happens is people look at the job rec and they're like, oh my God, I can't tick all of those boxes. I'm not qualified, and they don't apply for the job. And this actually, there's evidence that shows that in particular, women and minority candidates are more likely to reject themselves by not even applying. Whereas white men tend to be a little more willing to take a flyer, well, I don't tick every box, but I'll try. If you hit a lot of the boxes and not all of them, that's fine. You should apply for the job anyway. You should be honest about what your skills you do and you do not have, but you shouldn't assume that because things are listed there, that they are going to expect you to be an expert in every single one of those things. And you will disqualify yourself by not applying for those jobs. Just, if it looks like a pretty good fit, apply, and then trust them and their process. If you're honest in your interview, trust them and their process to figure out what they absolutely must have or you'll fail in the job versus what's a nice to have. And maybe they have somebody else who has a few more of those nice to have, but they think you're going to be better to work with, better able to learn, so don't see those as a critical, you have to have everything in order to apply for the job.
Yeah, one thing I'll also point out that kind of gets at this is, academics, just by the nature of independent research, are very good at learning new things quickly. And so that's an incredible skill that, even if you say, yeah, I don't actually know NLP very well, But, an interviewer or a hiring manager who, knows academics will know that, yeah, I could point you in the right direction, or you could do your own literature search and probably learn this brand new thing relatively quickly. And that is, an incredibly powerful skill that people who haven't done independent research don't have. It's really hard to teach that without some kind of research project. And so, that's where I think a lot of academics getting into data science can pick up those skills very efficiently and quickly.
Something also to know about the interview process, at least the interviews that I conduct and a lot of interviews I've had, is that it is supposed to be a collaborative process. And so it's okay and encouraged in the interview if you aren't sure what to do to suggest something or get input from the interviewer. And if the interviewer is giving you input or suggestions, it's 95% of the time because they're trying to guide you in the right direction, not because they're trying to trick you. And so it's very hard when a candidate digs in or doesn't seem receptive to that input. And the thing that we're trying to figure out when we do that is this person going to be a good colleague? Are they going to be collaborative? Is it going to be easy to learn together? And if you're not kind of open to that, that can be challenging. And I think it's hard because often in certain academic circles, you're kind of trained to fight for your idea or kind of push back or be a little more aggressive. And that's not usually how teams work in industry.
I would add to that and say an interview is not an oral exam. It is a conversation. And so I think while in an exam setting, it might be acceptable to sit in silence and think for a bit, that becomes very awkward either on Zoom or in person at a whiteboard when you're doing that in an interview setting. So I think treat it like a conversation. It's okay to ask questions, and it's okay to warn your interviewer. It's like, let me think about that for a second. Or can I take a moment? Can I ask a clarifying question? By that, do you mean X? It's like, and that those are excellent qualities. If you can do that, it's like if you're sitting down with someone to discuss a work project or shooting around an idea, that's exactly what you want to do. So yeah, not an exam, it's a conversation.
I would go even farther and say it's a conversation. It's almost like a first date. And it's a two-way thing. Like you are interviewing them and they are interviewing you. It's a sort of a joint conversation about, is this a collaboration that will work? Is this gonna be a fit in both sides? So this comes back to if you do some research about the company, do some research about the job, have questions to ask them. Because first of all, that's your chance to get more information about the company. And if you and like Jess was saying that a lot of the time interviewers are trying to help you, they're trying to get you to think with them in real time to test your collaboration. If you do wind up in an interview where the interviewer is antagonistic, forget it. You don't want to work there. You don't want to work with that person. That company culture sucks, right? So come in to it's a two-way conversation. It's a two-way street. You are interviewing them. They are interviewing you. You are both on both sides. You're hoping for a fit, right? When people interview for jobs, they're hoping to find someone to hire. So everybody comes in wanting it to work out. And the question is just, is it going to?
All right, we're coming up on time. I've noted down a few questions that people had in Slack and in the chat, and we will hopefully get back to those in the discussion, second discussion section a little bit later, which will talk a little more specifically about the job market as it stands this year, which is, as we all know, unique in the history of the universe. I'm confident in saying that in an astronomy conference. But let's go ahead and transition over to our final pair of speakers. So next up, we will have Genevieve Graves from IO talking about startup, consultant, or big company. You're muted, Genevieve.
Doesn't work. I am speaking without slides. I have some notes that I will put a link in to both Slack and the chat here, so you don't have to try to remember everything I say. And I think also things are getting recorded. but I like to use slides when I have data that I'm trying to present, and this is actually more of a conversation. So I prefer to not use slides when it's more of a conversation. So I'm gonna just start giving a very brief history of how I got to where I am, just as context for the conversation. But I actually want to spend most of my time today talking about different types of workplace environments. And fundamentally, what the question I'm driving at is sort of, what kind of a data scientist are you? And what are you interested in? And then given that, what are the landscape of things out there? How are they different kind of at the meta level? Like take away, okay, data science, machine learning, analysis, and talk, what is the meta level of this job? And helping you to figure out which part of that landscape may be most interesting to you. So I have a PhD in astrophysics from UC Santa Cruz. My background was in galaxy evolution, and in particular, I was an observational astronomer using data mostly from the Sloan Digital Sky Survey. So I was already a data scientist in the sense that I was working with, you know, tens or hundreds of thousands, in some cases, hundreds of millions of observations, data points on distant galaxies, and then trying to take some of those analysis skills sort of out into the data science world. I did a postdoc as a Miller Fellow at UC Berkeley, and I was less than a year into my second postdoc at Princeton at the point at which I decided that I wanted to do something different. This was in end of 2013. I wound up basically just started to talk to some people that I knew who were in industry, and I got connected up with and wound up joining a very, very early phase startup. I was employee number 1. They had just raised their first seed funding. So I was the first, there was a single founder. He was a business and salesperson, totally non-technical. So I was the first technical person in the company. The first thing I did was basically help hire a CTO and start collecting data, because the company was sort of was going to be data science at its core. But to do that, you have to actually have data in the first place. So we were just trying to get the basic gears turning. I was with that company for about 3.5 years. So we built it up from being, you know, basically me and the founder to being about 30 people. At that point, I decided it was time to go off and do something different. And since then, the company has pretty much exploded. We got involved in a complex legal battle with LinkedIn and Microsoft, and that is actually an interesting story, but it was not good for business. And in the meantime, I left that and I started doing consulting work. So now I run my own data science and data engineering company. It's me. I have a partner who's a data engineer. We have a few more junior people that we bring in for projects as needed. We have probably, at any given time, we have about half a dozen different clients that we're working with. And in that context, I have worked with sort of larger, later stage, sort of mid to late stage startups. I have worked with small companies that are not technical companies, but that have specific data science type projects they want to do. And I have been running my own business at the same time as part of that. So I thought, and I also, my husband is a software engineer at Apple. I have a bunch of friends who are data scientists or engineers at large companies. So what I wanted to try to do here was bring some of the context of what these different work environments can look like, because they are quite different culturally. And I think often if you're kind of coming into the job market out of academia, you have no idea what that landscape looks like and how these things can differ from one another. So the main thing I want to talk about is sort of like understanding who you are and what kind of a data scientist you are. And actually, in order to do this, I think it's actually something that we typically don't do as academics. We don't spend a lot of time in introspection. And part of that is because there's what I would call a target personality in science. You know, or maybe there's a couple of them, but there's this idea, well, I think many of us have this idea of what we should be in order to be a successful scientist in terms of how we work, what kind of work we do, how we communicate about that work, even what we do and do not enjoy right? So we feel the need to sort of signal that we like certain things that we may or may not actually like. We can signal work habits that we may or may not actually have. And there's a large sort of loaded value judgments that go with a lot of our identity in terms of how we think about ourselves. So one thing I want to convey is that in the business world, there's a very broad landscape of jobs, of sort of personality types that are useful, and they're useful in different ways. And so there isn't a right or a wrong way to be. And what I want to do is I want to actually get you guys to ask certain questions of yourselves. I'm giving a homework assignment here. And I have 6 questions that I'm going to ask. And again, you don't have to take notes because I'll share my notes in Slack and in the chat here. But these are questions that I think we are not taught to ask, and often are hard to answer because we think there's a right answer to them. So my first question is, who are you, or like what type of data scientist are you? Are you a scientist? Are you an engineer? Are you an artist? Are you a wizard? There may be other categories as well. Okay, and so what do I mean by that, right? So the reason I came to this question because I discovered partway into my second postdoc after more than a decade as an astronomer that I am not a scientist. I'm trained as a scientist, but I'm not a scientist. And what I mean by that is that, to me, a scientist is someone who gets obsessed with questions about how the universe works and why it is the way it is. And they care passionately about those questions. And they, are targeting or trying to answer those questions. And they're very motivated by that. That's not me. I'm an engineer. I'm perfectly happy to have somebody else come to me with a question or a puzzle. I like solving puzzles. So I like the process of solving a puzzle and doing science. But for me, the payoff is the challenge of working on the puzzle and then being able to solve a puzzle that makes somebody else happy, does a thing that is useful to somebody else. That is an important part of my payoff system. So I'm more of an engineer, really, than I am a scientist. The irony is my husband is actually trained as a software engineer, but he's not an engineer. He's more of a scientist than I am, in that he's actually motivated by those questions. Some people are also artists in the sense that there's this creative process. They don't actually care so much about the universe the way it is. What they care about is creating sort of self-consistent worlds. And being able to take that creative process and bring it into their work is incredibly important to them. So these are the kinds of people who, for instance, in the business world, might do well moving into sort of a product direction, like taking data science and turning it into a product where there's this creative process of trying to figure out how do I want to make something. I want to make something that didn't exist before, right? That's sort of an artist impetus. Whereas a wizard is somebody who really enjoys and validates on kind of digging in really, really deep into maybe the obscure arcana of someone. They know the incantations. They can mix together the spells that unlock something that most people can't do, right? And that's, again, so all of these archetypes are important, are valuable. For me, I think it was very hard for me to accept that I wasn't a scientist and to even see the parts of me that didn't enjoy being a scientist, because I had been raised and was living in this community that was a science community, but I'm not a scientist. So I think, the first question I would encourage you to ask yourself is, what am I? What do I enjoy? So that's question 1. Question number 2 is closely related, which is, what is your validation payoff? When you have a good day, what happened in that good day? What made it good? Not what do you think should make you happy? What do you think should make you validated as a scientist? But what actually do you enjoy? Presumably, if you're doing a PhD and you're anywhere near finishing it, there were things you enjoyed about it, right? Because a PhD is not an indicator of intelligence; it's an indicator of persistence, right? You were doing it because there was something you loved. What was it? Ask yourself that question honestly. What are the good days? What do they look like? What was in them that made them good? That was interesting or exciting or engaging or validating about your work? What were the bad days? right? If you had a bad day, what happened? Why was it a bad day? What made you not feel good about yourself? And think about like, what is it that actually makes you happy? You've got to put the sort of value judgments down of what should make you happy, what should you enjoy, what should make you feel validated, what actually makes you feel validated in a day. Because that's what you're really looking for in a job, is one where you actually feel like you're contributing and you are getting validation in exchange for your contribution. Question number 3 is in some ways a more sort of easy focused one. Do you like long projects or short projects? PhDs are long projects, right? Typically you're going very deep on something, you're researching it in exhausting, gory detail, and then you're writing a paper. Then there's things that are incredibly satisfying about that, right? Like I remember as an undergrad always feeling like I never had enough time to do anything well. Well, as a graduate student, I got to do things well. I spent years doing things as well as I possibly could. There are things that are great about that process. Fundamentally, I got frustrated with it. One of the reasons I left academia is because I got bored. Like having to do projects at the level of detail that science required. Like by the time I was writing a paper and submitting a paper, I was so over that project. I never wanted to see it again. I never wanted to talk about it again. It was just too much, too long. So again, so you can think of it like, do you like doing the kind of that sort of like early exploratory work that lets you write an AppJ letter, or do you like writing an AppJ supplement paper? There isn't a right answer or a wrong answer, but they're two very different things. And different types of jobs in data science, you'll find yourself working on much longer term, slower moving projects versus much shorter and in some ways shallower projects where you're trying to get something done quickly, but you're not going to have time to really go into the depths of it and do it all the way. So that's a question. What do you enjoy? Question number 4. What do you want to learn in your job? Right? Because we're all going to be, any kind of technology and data science, you're going to be learning new things continuously. And the skills, what data science was when I came into the field in 2014, different from what it is now, right? So I have to be continuously learning or I become obsolete. So this comes back to the sort of, do you like being super deep? You want to be a super deep expert in specific things, or do you like going broad and getting sort of breadth across things, or do you want a combination of the two? Different types of jobs are going to require different things. Another question to ask about what you want to learn: do you want to learn technology, or do you want to learn about applications of technology? Right. So do you want to become a super expert at something like natural language processing, and you're really interested in the algorithms, and you're interested in the science of how do you do better NLP? Or are you more interested in using, NLP is just a tool. You're interested in using this tool to do a job, and what you're really interested in is the application of that tool or the capabilities it can unlock. Question number 5, do you want mentorship? Right, so some jobs you're going to show up as a junior member of a team, and you're going to get mentorship, people who've been doing this for longer than you, who can teach you things. And I've talked to people and interviewed people who are like, this job is not interesting to me because I'm not going to have a mentor. This is a new subfield for me. I want a mentor, and I totally get that. That was not me. I was at a place where it's like, I've been a grad student, I've been a postdoc, I am done being an apprentice. I want to be in a place where I actually not only get to make decisions, but have to make decisions, and the buck stops with me. And if I get it wrong, I get it wrong. There's no I was like, I'm done with the bumpers. When I'm bowling, I'm done with the guardrails. I just want to get to do my thing. But for some people, they're like, this is a new thing. I'm not ready for that. So think about, do you want mentorship? And is a particular job going to give you that? And then question number 6 on my list is, are you interested in kind of a soup to nuts position where you are, like when I came into my first job at the startup, we didn't even have a data set, right? So we had to start by gathering data, curating data, figuring out, are these even the data that we need? Go back to that, you sort of build the entire edifice up where at least something about every single piece of the system. Or are you like, oh my God, data cleaning is the most boring thing in the world. I just want to build cool models, right? And then you want to come in at a much more mature level in terms of the company's trajectory or the data collection phase. So I'm sort of using these questions. I think these questions are important questions to ask. They're not necessarily easy to answer. It took me years to answer some of them. I'm still working on some of them. But I want to use them as a context for now talking a little bit about these different types of companies in different phases to try to give you a sense of what that landscape looks like. So I'm going to start with early phase startup because that's where I started. It's definitely a breadth, not depth place. And it's also sort of a soup to nuts kind of place, because at the beginning of a company, you got nothing, right? You are trying to go from 0 to 80% as quickly as possible, like before the house collapses on your head. And what that means is that you don't have time to do anything perfectly. You don't have time to do anything right or like fully correct. You are trying to get the absolute like basic framework that just about pretty much functions in place quickly, so that you can get up and running and start getting customers and building a business, and then you can improve later on. So some of the downsides of that are that you don't get to do things in detail. You don't get to, like, as a scientist, it's really kind of scary because you're out there on a limb and you're making claims that are probably true, but you're not 100% sure. You would never publish the paper, right? But you got to move forward with the business. There's this concept called MVP, or it stands for minimum viable product. When you're an early phase startup, you're 100% focused on the minimum viable product, emphasis on the minimum, right? So you're just trying to get the basic things there. Some of the other things that are true about early phase startup, you're the expert, right? If you're being hired as a full-time data scientist in a really early phase startup, they don't have a team of 10 data scientists because they can't possibly afford it. They've got like 6 people in the whole company, right? So it's just you. And you're going to do the best job you can, and the buck is going to stop with you when it comes to the data science. That can be exhilarating. That can be scary. It also means that you are working with people. For the most part, you're collaborating with people who are not like you. They are not data scientists. You're talking to all the other people in the company. And it means you actually are potentially involved in and have visibility into all of the other parts of the company. So you get a pretty holistic picture of the business because everybody is involved in everything. Like if you're there and you're technical and you're a good communicator because you're an astronomer, you know how to talk to people, you're going to be the sales engineer, right? You're going to be the person the salesperson brings in or the CEO brings in when they're trying to close a deal and they're talking to a technical customer. And that salesperson doesn't really understand how things work. So they're going to bring you in to help with the selling, right? Some people love that, right? They're like, oh my God, I get to see every piece of the business. If you're interested in maybe someday founding your own company, working for an early phase startup is a really great way to get to see this, like, broad piece of it. You might wind up being involved in fundraising, talking to investors. You'll certainly be involved in sales and customer success. There's also whole issues around stock options, which can be really important in startups. I could give a whole talk about the differences in stock and stock options at different stage companies. The main thing to know is just that if stock is going to be an important part of your compensation package, you have to talk to somebody who knows what they're doing and who's been around the block before, because stock means very different things at very different phases. And it's not obvious. It's not like you can't figure it out yourself necessarily, and it will not be explained adequately to you by the people who are making you the offer. So mid to late phase startups, I think are sort of an interesting in-between time. A lot of the time, they actually want quite a bit of depth, right? Because now the company's matured on, they're trying to do something really well. Data science may be at the core of their business. And so doing the data science extremely well becomes a key part of their selling point, right? They need more than just the basic framework in place. So there can be a lot of deep, chewy problems to work on there. At that phase, you're going to start to get to collaborate with people who are like you, right? Because there is going to be a data science team. There will be other data scientists to talk to. There's a mentorship is going to be more available, again, because the team is bigger. So if you're coming in as a junior person, there are likely to be people who've been part of the company for a couple of years and or have been in data science for a while that you can learn from, which is super valuable. Also, because the companies now, they're sort of moving beyond MVP, they're trying to actually establish excellence at what they do. Some of the projects will often be sort of longer term projects. You actually have a little more time, you're trying to do things a little more thoroughly, and you get to indulge that sort of PhD student desire to do it right, and get to a slightly more complete place with it. And the other thing, but there's some, stock also is off, stock options are also often an important part of the package there. A critical thing to know if you're joining a mid to late phase company, but one that's still private, they haven't had an IPO, is that most of the time you will not be able to exercise your stock effectively unless you stay with the company until they IPO. And if you leave before that IPO, you have an illiquid asset you cannot sell on the open market, and you have 90 days to decide whether or not to invest thousands of dollars of your own money to buy and hold that stock. So stock that comes from a kind of mid-phase company comes with strings attached, and part of what it's there to do is to try to hold you in place until the company IPOs. So it can be kind of a longer term commitment. I've never worked at a large public company, right? So I know a bunch of people who have, these companies are often referred to as FANG companies. FANG stands for Facebook, Amazon, Apple, Netflix, Google. People keep adding extra letters to it, sort of turning into a longer acronym. But right, these big tech companies that sort of dominate the Valley. At those companies, it often becomes much more about depth. You're working as part of a big team. You've been hired to be an expert in a certain thing or to focus on a certain thing. So you're going to be working much more narrowly and potentially more deeply. You're going to be mostly working with people who are like you. You have usually almost no visibility into the business side of things, and what's happening with sales and with customers and stuff like that. There's also, you are absolutely at a big company and going to go through an apprenticeship phase, in part because they all have their own bespoke internal systems that are different from everyone else's. And you're going to have to go up a learning curve on their specialized software stack, and like even just learning how to use the tools can be time consuming, interesting, but they tend to have sort of their own thing going on. Big companies are a place where you can go and you can have a long career in the same place, right? When you join an early phase startup, startup is probably going to fail at some point because most of them do. You join a mid-phase startup and it's sort of, it's a little more stable, but at a big company, you can do this, you can join a company and expect to be there for years if that's the thing you want. Typically they pay better. You're given stock that's actually worth something on the market. You can immediately turn around and sell it as soon as it vests. So it's a very different beast than stock options. And I think there are ways in which that institutional environment and the stability of it has more in common with the long-term academic careers that many of us were sort of aiming for when we first joined academia. Finally, I want to talk a little bit about consulting, which is what I'm doing now. And I will point out that consulting can happen like in a small firm, like I'm running my own firm, you could be an independent consultant. It can also happen within a large company. So some companies have things that they'll sometimes call it like a data science center of excellence or something like that, where essentially what they have is they have an internal data science group that does consulting projects for other parts of the business. And this, in some ways, has a little bit of the best of both worlds, right? You get sort of you get projects that turn over. So every few months you're working on something different. You get to see different parts of the business. There is this sort of combination of breadth and depth, but it has big company stability in a way that smaller companies don't. The flip side of that is, for me as a consultant running my own business, I have a ton of flexibility. And that has turned out to be super valuable because, for instance, we're now all working at home. Our schools are closed. So I have an 8-year-old. I am homeschooling my son in collaboration with some other parents. And I'm able to do that because I can take 2 or 3 mornings a week and just block out 3 hours in my schedule and be like, I'm teaching during these hours. So there's ways in which the flexibility of that lets you adjust your life and kind of write your own ticket. And that can be super valuable. I think we're running short of time. So I think the last two things I want to say is just that I think there's a critical thing to remember coming into a job search when you're leaving academia, entering data science, which is that you are a data scientist. You're already a data scientist. And however you answer those questions that I asked earlier, you can be a data scientist doing those things because it's a very broad world. And I think that coming into it and saying like, the question should become more like, what kind of a data scientist do I want to be? Which hopefully asking some of these questions and learning some about the different companies you could work for will help you answer. I think I'll end by just saying in brief why my pitch for why astronomers make good data scientists. And when you're in a job interview, you should feel free to use these things. One of the questions, like I've literally heard data science managers say things like, how do I get my data scientists to understand like the context of the problem they're working on, or like what actually matters? And to which my answer is like, well, you should have hired astronomers, basically. I think that we're all trained in this idea of order of magnitude analysis, right? Sometimes that's a thing that we practice formally as students. If you've ever been involved building an instrument, or you've been using data that comes out of an instrument, you are familiar with the idea of like an error budget, right? There's all these different sources of noise or error, and you are totally dominated by whatever thing is the worst in your system. So when you're trying to solve a data science problem, you're dominated by whatever sucks the most in your system. And the answer is almost never, I need a more powerful algorithm or a more sophisticated algorithm. The answer is usually, my input data suck, or I don't have enough input data, or the data are a mess, or the information I care about is not actually contained in my input data set. Like, so just that ability to pull out to the meta level and ask, what problem are we trying to solve, and what's holding us back? And then drilling in on whichever piece of your system is actually limiting you, as opposed to saying, oh, well, I think I know what the answer is. I think the problem is going to be this thing. Why don't we spend 3 months, trying to develop a new kind of model or whatever it is, right? You want to ask the question empirically, what's holding us back? And then you want to focus on the thing that is the biggest limit in the system. And I think astronomers do that extremely well because we're trained to think in that kind of way. I think I'm going to just stop here. What I do want to say is that if any of the sort of ideas that I've raised have given you questions that you want to ask, you should feel free to, obviously ask them in the Slack channel here, but you should also feel free to reach out to me offline when you've had more time to think about it. And I'm totally happy to engage in dialogue with some of these things offline. I've gotten exposure to quite a lot of different pieces of startup. So if you're thinking of joining a startup and you have questions about that are more specific, feel free to reach out and ask me, because I have over the years learned some things that I wish I had known at the beginning, many of which are easy to explain, but they're not necessarily easy to find answers to when you just Google them online.
All right, thank you very much, Genevieve. That was an excellent overview of various sizes and types of companies, and is a great segue into our final talk by Taka Tanaka, and then that will be a great segue into our final discussion section. So we are going to let Taka take over, and we'll talk about building a data team in the year 2020 to be updated for 2021, because he's figured out the whole year plan already, I'm sure, no problem. And then that'll transition into our final discussion session about the job market and data science positions and companies in the year 2021.
Great.
Take it away,
Thanks,
Tom.
Jeff.
Yeah.
Awesome. So obviously this is the wrong title for this talk. Turns out 2021 has not been better. So it's really in the 2020s, the roaring 20s, they used to say. Anyway, who is this talk for? I'm hoping you'll get something out of this if you are someone who is looking for more support from their advisors or supervisors. Maybe you're on the job market and you want to gauge how the company's thinking through the recruitment and the team building process and the management process. And then maybe you're already someone who's managing people, advising people, and maybe you're just a colleague who wants to help their team step up and be more supported. So I hope that you will get something if you're in one of these groups, or maybe this can just be an acknowledgement of our shared experience in living in pretty messed up times, and just acknowledge as a group that this is hard for everyone and we're all trying to figure this out. I am not an expert. I have been at my current role for 6 months, slightly less. I'm not going to, this talk is not meant as a mansplaining session of things I've done great. I'm not looking for a good guy badge. So that's not my intent. I'm just trying to share what I've experienced and learned. Quick outline, really quickly, I'm going to go through background about myself and my company. I'm going to talk about recruiting and hiring, both from this perspective of the company and for you, the candidate. I'm going to talk about work-life balance and wellness. I'm going to touch on logistics of doing that, and the empathy, the emotional support of supporting your team in wellness. And then I'll touch on the work, again, from a binary perspective of the day-to-day and the big picture. All right, jumping into background. Where am I coming from? So I got a master's once in a PhD program. I dropped out of it. I worked some odd jobs for about a year, decided, hey, I really miss the academic thinking. So I went back to get my PhD in astronomy. And then I did a couple of postdocs. And then I left, did the Insight program. And as we'll talk about in the breakout session, that program is no longer running. But through that program, I became a consulting data science. So I became a consultant advising companies on how to build up data teams or data products. Maybe they had a problem with business strategy. And my job was basically to come in, talk to CTOs and CEOs and said, well, here's your problem and here's the solution, and do then like a 3-month time scale. So that's the background that's the context of the first job I had as a data scientist. Then I left that company, and about a year and a half ago, a little less, I was brought into WW, formerly known as Weight Watchers, to begin a new data team. So as the previous speaker was saying, this is an internal consulting role where I was building up a data science consultative function within the company to solve big business problems. Then COVID happened. WW having a business partially built around in-person studios was hit particularly hard. There were many layoffs, some of which have been written about in things like the Wall Street Journal. One of the layoff casualties was my boss. And with her went this vision of building out this functionality. I started thinking about, well, can I accomplish the goals that I set out to do when I joined this company? Reached out to this company, actually skipped order. I started talking to them in March because they needed some advice on how to build a data function. So I had that conversation, things went down at WW, and I reached back out to them, and then this role materialized. The company is a mobile fiction app that offers spicy bite-sized stories, hence the name. There's a lot of romance content on the site. We have roughly 50 employees globally. We're a past Series A startup, so this is a mid-sized company. We have 60 million rounds of total funding. We're located mostly in New York and California in the United States, and about half the company is located in Korea. The team grew from 1 member to 6 in about 4 months. So I was the second data science hire. So prior to that, for about a year and a half, there was 1 data scientist at the company. I came in at the director level, then hired 2 people in the team, and then we're adding 2 internal transfers. And we also have a separate data engineering team of a couple of people in Seoul. I've never met any of these people in person. I have no idea how tall they are. I have no idea if they are centaurs. So that's the context. And this is a simplified org chart. So I report directly to the CEO. So I manage about 10% of the company. And then, so I have I have a pretty good view into the whole business. Okay, recruiting and hiring. How did I think through this? Well, I had to quickly learn about what the company needed. So I took a lot of time to talk to different group leads and figure out what the business needed. I think one thing that any data scientist at any level has to ask is, well, what is the data infrastructure like? Thankfully, Reddish has a very mature data system, especially for a company this size. We actually have a data engineering team. We have very solid data that we can actually query, and it works really well. And so I think less mature companies tend to start at the descriptive stage of the data. So in one of the previous talks showed a pyramid. So this is the same concept. You want to build your data infrastructure. You want to have relational databases. You want to query it to understand what's going on. And then as the organization and the infrastructure matures, you want to have the capacity to predict what's going to happen and then prescribe the actions, but depending on what the data is telling you. So I had to assess where the company was. Then I thought about, do I need generalists, specialists? Do I need hackers? Do I need deep knowledge engineers? As a hiring philosophy, I tried to get people with different technical skills and communication styles. If one person on the team is gregarious and very good at communicating ideas, maybe we needed someone, we would benefit from having someone that was a careful thinker and a very reserved speaker, people who were willing to ask for help. We were already in full lockdown several months into the pandemic at this stage. Remote communication skills was something I emphasized. And then people who had thought about stress management and self-care, and people who knew how to ask for help when they needed it. And I was very deliberate and patient in looking for the right candidate, even though the company needed this capacity. Someone that an old teammate of mine said a few years ago at another company is, I'd happily do 15% more work for a while if I'm not working with someone or if I'm working with someone who's not awesome. And I tried to take that mentality and find a truly great people that I could root for. Another thing that I thought deeply about is a paycheck is not an opportunity, right? So like yes, it's a job, but I wanted people who saw this as an opportunity. And I think this is something that's important to talk about to think about when you're looking for jobs, right? Is it a job or is it an actual opportunity, right? Do the company prospects fit your risk and reward tolerance? Are you comfortable with doing the company's business? In our case, are you comfortable publishing romance fiction? What are possible paths for career growth and personal development? Do they align with your goals? What are the perks and benefits? What extras can you ask for? And I, as a hiring manager, what can I offer? And then, as a team leader, can I offer them the kinds of work that they're interested in doing? If these things aren't going to work out, there's no point in hiring someone, no matter how skilled or talented they are, because a few months down the road, they're going to be getting offers from companies that do offer them the things they want, and then they're going to leave. I put a ton of thought into hiring inclusively. So things like minimizing bias, introducing language in the job description, interrogating the experience they need for the job versus nice to haves or things that someone with their background should be able to pick up quickly. Interrogating qualifications, like does the job actually require a bachelor's degree in a quantitative subject, or do I just need someone that's demonstrated that ability? Prestige of their affiliations, I tend to not look at. I always had women and people of color in the interview group. I anonymized data challenges where it was practical to do so, being a small company. Sometimes, the candidates coming in and that's not always possible, etc. And then remote interviews are awkward where no one's, very few people are experts in that. So when things went wrong, I did my best to say, hey, do you want, I thought there was something there. Do you want to continue the conversation? And then where candidates, clearly just did not meet the technical qualifications or for whatever reason, we had to say no to. I did try to schedule some time, or if the candidate kind of flunked the interview in the first 5 minutes, I tried to spend the rest of the time kind of trying to talk them through, okay, what do you want to look for? And, what other companies have you looked at, that kind of thing. At the end of the day, we hired people with very different backgrounds, or the team ended up having a diverse set of backgrounds. The original data scientist who was here before I joined has a degree in finance and mathematics, has a finance background. I hired a PhD with research experience through the Insight program before they died. We hired someone with a background in drama studies and TV production who went through a boot camp, and she's currently a data analyst. Then we have 2 internal transfers with very unique backgrounds, you can see here. I'm kind of rushing through this first part because I do really want to touch on this part. If you take nothing else away and I get to talk about this stuff, I think I'd be happy with this talk. So it's been said we're not working from home, we're living at work. And I firmly believe the following 3 things to be true right now. Employers have unprecedented impact and access into the personal lives of employees. Like, it is hard because Zoom is in your living space. Meetings are happening in your living space. Things are happening when you have kids running around the house, you have family members worried, and then you have attacks on the US Capitol. Everyone is going through some shit every week. And then the last part is you hire someone because you're excited about what their A game looks like and what their future will look like. Like, don't hire someone if you're not going to be excited for them, if you're not going to have their back when something happens, if you're not going to be willing, able to trust them when something goes wrong. So one of the things that I really tried to set out to do was set boundaries between work and home. And one of the simple things I think you can do is architect the team's schedule for predictability and flexibility. And for me, that meant purposefully arranging large blocks of event-free time. That has 2 things. It sets a rhythm. So if Tuesdays are your meeting heavy day, and your partner or people in your living situation know that, then that becomes easier to plan around. So my wife knows Tuesdays are big meeting days. And then Thursdays and Fridays, I usually don't have meetings at all. And that sets a pattern. You no longer have to worry about, is today Wednesday or Thursday? It helps set that rhythm. The other thing I think it does is it makes the non-work meetings more meaningful. So if you're scheduling a team tea time or happy hour or whatever to bring the team together, if it's one of 4 other meetings that day, it's going to feel like, oh, I've got another work thing. So I tried to separate that. I loudly and repeatedly encourage breaks. I don't care if you have a doctor's appointment. I don't care if you have a scheduled Zoom call with your family. I don't care if you're going for a walk, do it. If you're going to be gone a while, just let people know. Then I tried to follow through on that. I think we all know advisors who are kind of workaholics and set unhealthy examples for their advisees. I tried not to be that boss. Even if I'm working late for something that I have to do for the CEO or whatever, I tried to do that in secret. And then protect your team's time from stakeholders and leadership. You are the wall of sanity and knowing what's possible and what's reasonable between people in a small company with extreme amounts of power. And for new hires, that can be very scary if you have, a VP slacking you or people asking you when something's going to be ready. Like, be the wall that communicates and delegates the management's requests to the team. So this is my actual schedule from last week. This is pretty typical. Mondays, so the blue things are meetings, green things are personal things, and purple things are kind of higher up meetings. That's just for me. But I color coded it because if I look at the blue, I know what my team is looking at. So I know how their meetings are spread out, what their day looks like. So Mondays we kind of sync in, figure out what we're doing for the week or just remind ourselves. Tuesdays are meeting heavy days. Every other week we have stakeholder meetings. So we have marketing team, live ops, product, all of that. We have a US team all hands. Then in the evenings, I have meetings with the CEO and the COO and all of that. Then Wednesday mornings, we kind of take time to do a sprint plan. Hey, what did the teams need yesterday when we talked with them? That sets the plan for the next 2 weeks. And the stakeholder meetings also happen every 2 weeks, and the sprint plans happen every 2 weeks. It's like you meet with the stakeholders, do the sprint plan, you're sprinting for 2 weeks, and that sets a cadence. And this is also the time where I have my one-on-one check-ins with my team. I'll touch a little bit more on that later. And then Thursday, the only regular meeting we have is team time. Just grab some tea. What did you watch on Netflix lately? What did you do for the holidays? Things like that. And then Fridays usually free. We might have a journal club here and there. Again, consolidate meetings, set a pattern, normalize blocking off time. My schedule is public, so people can see when I have personal time blocked off. Again, these are the blocks of free time that my team has. And then the other thing I wanted to mention is work should happen around life, and a manager has a ton of influence over their teammates' day-to-day lives and schedule. This is election week. I mentioned we have Tuesdays as our meeting heavy days. Several weeks ahead of time, I moved all of our meetings to Mondays or Thursdays. So nothing going on election day, nothing going on the day after. I thought that was really important. We're going to be distracted. Tuesdays can be very busy. So let's try to and I told the team ahead of time, let's try to get things done as much as possible by the end of the day, Monday and maybe Tuesday morning, so that as distracting things start happening, we can deal with it and we don't have to worry about work and take a day off if you need to. Again, the world is scarier now than at any point in probably most of our lives. And work should not add anxiety. It shouldn't be a thing of like, am I going to have my job next month? Is my boss happy with the work? Those things should not be a factor right now. Last week, we all know what happened. The least I could do as a manager is say, hey, it's really messed up right now. Do whatever you need to do to take care of yourselves. Support your team. Some of you might know this meme. Create a supportive environment. I mentioned one-on-one time. That is a time that I use and to talk about employees, how each of my teammates is doing. I don't talk about their project work unless they want to. So how are they doing? Do they need anything? What can I do to help? Is the work that they're doing still aligning with their goals? Are they excited about it? What's been frustrating? Talk about those things and not, hey, what dashboards do you need to build or what color scheme? No, that stuff doesn't matter. We can do that another time. With new hires especially, reassure them like they need feedback. I think it's really say, okay, that was good, and then move on and then give a Slack thumbs up, and that's it. It's like, no, if the VP of marketing thought the work was really great and helpful, and they told you that in a meeting, relay that. It's like, that was really appreciated. That's great. And then check in with, are they excited? Are they staying motivated? Do they need a break? I'd much rather have my team running at 60% or taking time off than trying to run at 100% and falling apart. I think that's pretty obvious. And then I think everyone has a different limits for human connection versus getting Zoom or Slack fatigue. Working remotely, it can be hard to gauge whether someone's making progress and just not updating you, or they're stuck, or they have other things going on, and trying to find out can come off as being a little hovery. So finding the comfort zone for each of your teammates is something that I think we should all try to do. Then I'll go pretty quickly through the work. I don't think this part is nearly as important, honestly. We have a range of things that the company needs, from descriptive analyses and dashboards to predictive models. We're a product company, so we want to recommend things to our users. Onboarding, mostly, I'd say the focus here is on documentation and co-learning, so figuring out how to bring people up to speed remotely. So having a good documentation infrastructure, having regular syncs. So I think first week, it's like at the end of the day, it's like, okay, how was your day? What information were you able to find? What did you need to know but couldn't? All of that. And then making sure the first project is achievable, that it builds business context, that builds experience, etc. I think that's common whether or not we're working remotely. Clarifying priorities, knowing which ones are like the $1 million impact questions, super important for a company at our stage, versus the academically interesting or nice to have requests. And so I freely admit the first few months I was saying yes to what all the other stakeholders saying, and I said no. At some point I basically had to say, no, we can't do this because it's not high enough priority, it's not high enough impact. At a bigger company that's more mature, it might be great to have this dashboard, but right now we're trying to fix some other problem. So figuring out what had to wait, and then what things we could do to really sway the success or failure of the company. Yeah, and then making sure that the team is feeling accomplished and on track. I think I talked about this already. And then versus the big picture. So for leadership, really clarifying objectives. What does the company need? How does my team fit in? Setting expectations, like they can't ask for something and expect it to be done in 2 weeks. Sometimes research takes time. Sometimes building product takes time. Again, step up for the team and protect them from excessive work or unreasonable expectations. And then, guiding leadership on where precision is needed. Like, do you really need a precise reporting dashboard or an analysis? And where they just need order of magnitude to make a binary choice. Do we do X or do we not? And those are kinds of things that you can answer very quickly with the right direction and framing. So that's something that I've had to think a lot about. And then for my team, do they understand the company objectives? So just oversharing or erring on the side of over-explaining what the company is trying to accomplish. And then, just, is the work interesting? Are they touching the kinds of data? Are they doing the kinds of projects? Are they working with the stakeholders and parts of the business that they were interested in when they were interviewing for the job? And am I fulfilling the promise I made? Or it's an implicit promise. I didn't, get wishy-washy on them, but it's like when they accept the job, it's with an understanding that they're going to be working on some things that we talked about during the interview process. And so I tried to check in regularly on whether that's still going on. And then again, just connecting people to the company. We do have a weekly US all hands, but what else can we do? So I tried to lift up their work to the rest of the company. So we've started doing monthly data share outs. So like the data team's greatest hits from the last month. Highlight great work. It's like mention to the CEO, oh, this new hire did a great job on this. Give teammates opportunities to speak to the rest of the company. Ask their other teams to share out their work in meetings. And then I've been doing things like organizing new member happy hours and things like that. I've been talking a lot and we're just about out of time. So, again, the things that I've had to work on are quickly understanding company goals, finding amazing people, supporting them, and then defining the things that you want them to be comfortable with, and then finding the logistic levers that you can adjust to make that happen. was something that I spent a lot of time thinking about, probably every day. And then making sure that the work gets done in a reasonable pace, and setting expectations to make sure that the pace can stay reasonable as the company and its leadership has goals and needs. So that's about it. I'll stop talking now.
Thank you, Taka. Great job. Yeah, y'all can't do the clapping. But, yeah, this is a great launching off point for our final conversation, our discussion here. This I won't put up a slide. It's entitled "The Data/Tech Job Market in 2021." There's a number of questions, I think, as the main themes I'm seeing here that I'll just kind of highlight, and then people feel free to contribute and jump in. Seeing a lot of talk, Taka, of course, touched a lot on work-life balance. I think that is very important. There's a big difference between bumping into someone in the kitchen versus having to have a scheduled calendar one-on-one conversation to get a conversation going. Very much so with onboarding and coming to a new thing. And there was a number of questions I saw in the Slack that I wanted to bring up just about remote work and, people asking, did you move for your job? I personally did move to the Bay Area from West Virginia to get my first data science job. And, I kind of fell in love with the Bay Area, so I'm sticking around here. But, I don't think that's the case so much anymore in as Taka put it, the roaring 2020s. So, with that being said, I can, if anyone wants to jump in, that's fine. Otherwise, I'll start reading specific questions. I guess the first.
Can I jump in and just say something about the whole remote
Sure.
work thing? So one of my clients currently is a venture capital firm who are particularly interested in HR tech and the sort of what they refer to as the future of work. So they hosted a conference this fall about remote work, and they had CTOs, CIOs, and CEOs of a large range of tech companies, many of which are household names, and also big companies that are not, we don't necessarily think of them as tech companies because they're just, like Main Street, retail outlets, but they all have large software teams and large white collar workforces. The consensus among these hundreds of top executives was that the idea of working in an office has changed, and it has changed permanently. And there's still a lot of discussion about what the future is going to look like. But the future of work is going to include quite a lot of remote work, options for remote work. They see this as a huge opportunity. One of the big topics of conversation is everyone's like, at the beginning we were worried about productivity and would workers lose productivity? And everyone was like, we haven't seen that. What we've seen is that people are more productive. Now what we worry about is work-life balance, right? Like, because everybody's home is now their office, are people actually taking the downtime they need to stay sane? So there was a sense that it had been a huge plus for productivity. And that it also, a lot of people talked about how it opened up the possibility of hiring in much less expensive labor markets. So like, why are we paying top dollar for, to try to, squeeze more people out, into the Bay Area and out of the Bay Area when there's great people in other towns that have much lower cost of living. Now I have a bigger talent pool to fish in because I can hire across the entire country, or I can hire around the world. I can offer my employees benefits, like life benefits, other than just a bigger paycheck. I don't need to burn this much money on office space in a big fancy building downtown, et cetera. So there's the sort of executive powers running medium and big companies feel very positively about the future of remote work or partially remote work, of distributed teams, of less expensive labor market pools. And I think that's, I don't think anybody knows exactly where the future is going to be, but it's absolutely going to be part of the future. And there's much less pressure for people to be in a specific location than there was even just a year ago.
Yeah, completely agree. Looks like there's some answers for the question I was going to bring up, so I'll go to the bottom one here. But yeah, in regard to the upcoming conversation we're having here, Gregory asked, what's the best place to find data science jobs? Should we be scrolling through LinkedIn, trying to find companies that look like good fits and searching for jobs on their website? Just trying to find as many networking connections as possible. Any thoughts on that?
I think LinkedIn. Sorry, go ahead.
I was just going to say, I think networking is a huge aspect of it. And somebody did ask about networking earlier as well. And, you know, the fact that anybody on this Zoom call now has, how many of there? 6 speakers, 2 organizers. That's 8 astronomer turned data scientists that you should be LinkedIn connections with, that you could get an email address from, that can look over your resume or maybe give you some advice. And then they know, you know, it's a pyramid scheme at some level, right? We each know, there's some overlap, but, you know, we each know another 10 from our grad school cohort or our postdoc group or our research group, like our old subfield, right? And so, you know, that's a way to network and get connected and get multiple opinions on things and get access for jobs. I, you know, may or may not be hiring right now, but I might have a group, whether it's on Facebook or Slack or, you know, just a group of friends or email list, and say, hey, this resume looks really good and they're in this part of the country or they're interested in this field. You know, does anybody have an opening or does anybody want to, you know, talk to this person?
I think it's critical for people to recognize that a huge amount of hiring, even or maybe even especially at large companies, happen through what is called internal referrals, meaning someone who already works at that company puts your resume forward. And it makes a huge difference as to whether or not anyone even ever looks at your resume. I don't think it doesn't matter. Once you make it into a job interview, it doesn't matter, right? The interview is the interview. But whether or not you even get that first interview, it makes a huge difference. I mean, there's all kinds of biases and problems with that as a hiring measure, and people are aware of that. And I think there are places that are trying to do things about it. But the reason companies do it is because it is far and away the best pool of applicants they get, right? So you can imagine if you're Google, you get literally millions of applications for jobs. There's no, and they now have machine learning algorithms that go through that, but there's biases that get baked into those things too. So the best thing you can do is find, if you are interested in applying for a company, is to find a person at that company with whom you can have a conversation who will make sure your resume gets looked at. And it's called an internal referral. And you do not have to know that person well. They don't have to be a friend. In general, what you'll find is that people are very open, especially like in this sort of X-astronomy community. If you reach out, if you're somebody who worked in a subfield that you worked in and you've like read one of their papers, or somebody that who was a postdoc when you were a graduate student, you maybe had one conversation with them. This does not have to be somebody you know well. I even have had people reach out to me who I've never met, but they're astronomers, they're interested in this career transition. And if I'm not having a terribly busy day, I will usually respond to them and have a conversation. So people will be in general be very friendly and very willing to help, even if they don't know you well. But it makes it in many cases will make the difference between whether anyone ever looks at your resume or not.
Yeah, just to highlight that, when I was initially trying to make this transition, I was really worried about bothering people who were like in my extended network to get internal referrals or help. But a lot of companies will give referral bonuses to people that you submit to the system. And so not only like, do you potentially get this job or this inside track, but if you get hired, the person who refers you gets some sort of often monetary bonus. And so it's not, I don't consider it like bothering me if someone reaches out for a job. Like it can be very beneficial to me as well. The other story I have that I found really illuminating is when I was several years into being a data scientist, I saw this job opening at Wikipedia and I applied through their website and I didn't hear anything for 2 weeks, but this job remained on the website. And then I went on LinkedIn, I added a recruiter from Wikipedia, just requested them, cold. They accepted me, and then I sent them a message and I said, hey, I applied for this job and I never heard back from you all. Is it still open? Within an hour, they had called me. And so basically that's just, they had been flooded with resumes for this job on their site. Like they didn't look at me. And as soon as a person saw my message, looked at my LinkedIn, they were very interested. And so even if you don't have that direct connection, just any way to get a human to engage with you can really give you that bump in distinguishing you from the masses that are applying for a job.
You're also showing interest, active interest, right? You track somebody down and we're like, hey, I'm interested in this. That also just bumps you up the stack.
Yeah, I just had someone for different role, non-data role in my company. A former colleague I worked with at Weight Watchers forwarded me saying, hey, I know this person, they just applied to this job. I can recommend them highly. And I just said, well, I don't know this person, but I told my HR person, hey, this is someone that I used to work with that thinks really highly of this candidate. It can be as simple as that. I would say I totally agree with Jessica that don't worry about bothering people. It can be someone it can be a mutual acquaintance. It can be someone that went to the same college as you. The connection can be very superficial, but it does show interest. I would say be earnest and honest in your interest. I did have some negative experiences where people reached out and said, oh, your company looks really interesting. I really want to hear about your career path. Can talk for 20 minutes? And I said, sure. And then for about 20 minutes, they spent the entire time talking about how great they were. And then at the end of the conversation said, oh, by the way, I saw you have a job opening. Don't do that. It's really obnoxious.
Yeah, I'd like to kind of jump in here with seeing a couple questions on Slack from a couple people about boot camps. Have 4 out of the 8 of us, so half, I believe, Taka, Ben, Jeff, and myself, we all went through the Insight program, and the other 4 speakers you saw today did not. So I'd like to open it up though to anyone there who would like to comment on that before I answer the question myself. Okay, well, I'll jump in there. Yeah, I'll just say it definitely, I think it helped me at the time I was at. It helped me with my imposter syndrome, kind of thinking I don't know if I could make that jump from academia to data science. Aside from that, so what I kind of learned as I went through that program is that having a PhD and being a trained scientist, I had all the skills already. It was just kind of the answer's been within inside you the entire time. It's kind of the lesson you learn at the end of the journey. If anything, it helped me speak easier with business people and product managers that kind of, they don't talk about chi-squared in the same way a scientist does. You got to kind of think about how to communicate that a little better, and maybe you're using some stats lingo more than physics lingo, depending on what part of astronomy you're coming from. Yeah, that's kind of my thoughts on it.
My sense, I didn't do a boot camp. I know a lot of people who did. My sense is one of the really valuable things I got out of it was networking. So many of the boot camps actually help you with your career search at the end of it, which is helpful because they are very well plugged in, but also you meet all the other people in the program, right? So for me, my version of this is I worked for a very early phase startup for 3.5 years. That startup has now exploded. And what it has done is it has seeded dozens of people out into the world in different data science jobs who I now know. So next time I need a job or I have someone who comes to me who's looking for a job, I have a whole network of people I can reach out to, and they're all at different companies now because the startup exploded. Insight, I think, also functions that way. Like you meet people and then they all wind up, you're all interviewing for jobs. It doesn't necessarily help you get the first job to have that network, but within a few years, those people will have moved around. So I think that there's also, it can be, particularly if you are really uncomfortable reaching out to people in networking, it can be a little bit of a leg up on that.
Insight's also quite helpful or something like that because they do interview prep practice and coaching you around preparing for interviews and negotiating salaries. And often you can end up with multiple job offers coming out of Insight, which can be useful to negotiating your initial salaries and getting a higher salary than if you were not doing that. It is hard to time a job search on your own, so especially for your first job, so that you get multiple offers at the same time. So I think there's a lot of value there. That said, like now Insight is quite competitive. Very few people who apply end up getting in.
Well, zero now. It's shut down for the foreseeable future.
Yeah, but all right. So I'm talking about, I mean, even before it was shut down, I think it let in like less than 10% of the people who applied or something. And so if you don't get in, I don't think that is, or if it's not available to you when you're looking, I don't think that that's a non-starter. There's ways to have a similar set of benefits from your own network and your own set of work to Insight without having to go through the program officially or some other boot camp like that.
Yeah, one thing that I like to point out is, there's, I think in the Slack question, somebody mentioned that there's a variety of boot camps that are different lengths of time, some that cost, some that don't cost, some that cost a lot. While you could maybe get a small bump in your salary for your first job from one of these, most of the ones that cost a significant amount of money are just not worth it. You're especially the longer ones that do cost money, that are really like classwork and training you in the skills to be a data scientist. You have all of those after doing some astronomy and physics research. So that's not what you need. You need to translate some of the terminology like Josh was talking about. You need to bulk up maybe your networking, your actual networking skills, and doing the network and getting a network, and maybe some interview practice. And some bootcamp type programs do more of that rather than let's have 5 hours a day, 5 days a week on machine learning, right? Like that's a classroom thing. And you can pick those up online, or how to how to code already, et cetera.
Yeah, the hardest thing for me with interview practice, which was very useful in that program, is taking your dissertation that you worked on, blood, sweat, and tears for years, and condense that down to 60 seconds. Because, no one's going, you gotta have an elevator pitch where you can explain that you did all these things at a non-technical level, but most importantly, you also have to convey the skills you use that would be applicable to the job you're applying for or that you want to get.
So I've seen a few people, oh, sorry.
There was a question in the channel kind of related about a internship versus a boot camp. I actually think internships are more valuable than boot camps. If you can take like a summer out of your graduate school to do an internship. So one, they're normally paid, and they're normally paid better than you would be paid in graduate school. So it's a way to have some extra money during grad school. Two, often internships, especially at larger companies, turn into full-time positions after you graduate. And so it's pretty much an automatic place that you could go as long as you perform well in that internship. You'll also learn a lot of these technical skills like collaborating on code or using databases or some initial like modeling or analytics skills on the job, and you're not expected to have as high a level of skill as if you're a full-time hire. And so if I were to choose between someone who had done a boot camp or someone who had done a data science internship, I would personally rather hire someone who had done an internship.
Something that
question you're on kind of, oh, sorry. You want to
go ahead.
Okay.
Go ahead.
I think I saw a similar question further up. I don't know if it ever got addressed about juggling internships with graduate school. So if like you're a graduate student and you're thinking about one of these internships, like do you juggle them at the same time? Do you sort of focus on one or the other? What are people's takes on that?
I think if you try to do both at the same time, you'll do both really crappily.
Yeah.
Yeah, I guess there's one caveat is that I do know a few people that did internships when they were kind of all but dissertation, and they never then finished their dissertation. You can get really adjusted to the lifestyle of working and the paycheck, and then just decide not to finish. So something to be careful about if you care about actually getting that degree.
Yeah, I mean, practicing, like we talked about earlier this morning, practicing the skills and bulking up the skills that you that are applicable in data science careers while you're doing a PhD, while you're in academia, is sort of, you know, effectively doing an internship. There's a couple of differences, obviously, of how academic projects work versus, you know, in a company or in an industry setting. But like gaining those skills and applying them to an open question that may not have an answer, that you need to gather data to then answer that question. That's what I want to see, whether that's at an internship at Google or, you know, UT Austin for a PhD, similar kind of setup.
Okay, I think, yeah, that addresses all the last questions there. Oh, we got one more here. Networking and how important it is to get started in a career in data science. In academia, there is networking when finding collaborative projects. Are there networking skills resources within industry that greatly differ to what one might find in academia? I'm not sure I have a good answer for that one myself. Someone else.
When it's not COVID time, you can go to meetups.
Yeah,
which can be just you know, or talks or lectures, anything that you find interesting, and you can meet like-minded people there. I think one thing that's different from academia is have a LinkedIn profile. If you don't already have a LinkedIn profile, make a LinkedIn profile. People in business actually use it, and it's usually the first thing they will look at when they go to look at who you are. Yeah, having a GitHub profile is also, particularly on the technical side, is really important. Right, so use Git, you know, put some stuff in GitHub. That's the other thing people will almost instantly look at when they know that you exist.
This is probably networking like further on in your career, but I have found that being on boards is a good networking opportunity where you're able to collaborate with other senior folks and kind of understand what they do at their companies, and that can turn into executive hiring opportunities.
Something that's a little off topic and that's not relevant in your initial job search, but is worth keeping in mind. So as I said, one of my clients is a VC, so I've been sitting through a lot of meetings about just listening in on them vetting various companies and various people that they're interested in. And there's this idea that there's there's like a golden time frame to spend in one job or one institution. And I think this is not just true of VCs, this is also true of people who are hiring. If they see a lot of very short stints, less than a year or less than 2 years, again and again and again, they're like, oh, that person's a job hopper. That person's not super serious. The flip side is if they see that you've been, you know, if they see that you've been somewhere for 6 years or more, they're like, that person's a lifer. They're never going to leave. Or, you know, so if you are, you know, if you're interested in founding a company yourself, or if you're interested in sort of working your way through a landscape of different jobs, you don't want to spend too little time in any one place because it indicates a lack of seriousness. But also if they see you, if hiring managers or investors see you sitting in the same place for a really long time, they see that as a sort of a sign that you're not that ambitious or driven. So you should just be aware that both of those things send signals.
That said, I think
go ahead. The flip side of it, I think the flip side of it is that you should, you know, it's about creating the career that you want to have, obviously. But you also, I think many people who come into academia and think they're going to be in academia, they have a vision of being in a single institution for a very long time, and that's just not the landscape of a lot of the mainstream workforce at this point. So I think a lot, you know, I don't know about the other data scientists on this panel, but I've never taken a job expecting to be there for 5+ years. And I don't necessarily see it as a disaster if after 2 or 3 years, I want to move on or the company doesn't exist.
I intentionally went into my first data science job with the notion that like, I have my idea of what data science is going to be all about, and there's probably going to be some things that just turn out to be wildly different. So I wasn't super picky about my first data science job. And you know, hopefully down the line, you find what you really want to do in your data science work, and then you land on something that you could see yourself working in for the next 3 to 5 years. That's at least my goal, is to hope to get to that state.
Yeah, last I heard, the average length of a data scientist at a single position in Silicon Valley, San Francisco area was, I think it was 1.5 years, maybe 2 years. And so that's like typical, that people just move on, not because they ran out of funding or, their boss was fired, but because they want to move somewhere else, work at a different size company, work on a different type of company, and probably make more money, because every time you move, you can usually get a bit of a bump.
Yeah, and I guess I would just caution people to, shouldn't stay in a bad environment or a bad situation just because it's under 2 years. You can explain a move if, it's shorter or different than you had planned, if there's like a reason for it. I think the people that Genevieve is referring to are people who kind of have 5 jobs in a row where it's less than 2 years. And then that looks a little bit like, this person doesn't commit, this person's flaky, this person has some behavioral issue that doesn't come up right away, but comes up later, and then they end up getting forced out. So ultimately, there's no one rule of thumb for anything. So.
Okay, well, I think we're at time here at 5:50 Eastern time. We should break now so people can go to the plenary lecture. I'll do a plug here before we go. We are doing an evening activity at 6:45 Eastern, 3:45 Pacific here, where a friend of ours that owns a local San Francisco bar is going to teach us how to do a couple cocktails. The links are on the website, and we'll make sure that's posted in the Slack. And it'll be right here on this Zoom call as well. So thank you, everyone, for attending. This was really cool. Bye.
Thanks, Josh and Jeff, for organizing.
Yeah, thanks so much, guys. This was really great.
Yeah, thanks, everyone.
Yeah, definitely come by again, guys. Yeah, so Josh and Jeff stop by a lot. There's many late nights here that I remember Jeff used to come by after like a Sharks game, and then we'd be sitting here drinking until like 1 or 2 a.m. on a school night, even though we both had to work the next day. I just show all kinds of bourbons to drink.
I just remember that. That's right. There was a time that Josh and I were at a hockey game, and we drove back to the city, and we're walking by Reeves Bar, and it was like, oh, I wonder if it's open. And we opened the door, and Paul was like, I guess come in. I'm closing up, but let's try some of these nice whiskeys.
Yeah, I mean, that was kind of the reason why I wanted to buy a bar, because we used to go to bars, like you said, all the time. And then, for the last 20 years or so of our life. So we thought, if we go to the bar so much, let's just at least buy one so our friends can go and hang out. We don't have to worry about closing times and drink here until you guys are tired, whatever it is. So we did it. We tried to buy a bar about 10 years ago, and that failed. And we always kicked ourselves for it. We always said, oh, do you remember that bar we tried to buy? Do you remember that bar we tried to buy? And then we sat around drinking and talking and said, okay, well, if we had an opportunity again, we'll buy one. So we did. So we call it Reeves. It's supposed to be a place that people can get away. I don't know if you know where we're located, but we're right in the heart of San Francisco. So right next to the train station, not in the financial district, but near kind of the tech area of Soma. So a lot of companies are next to us. Pinterest, Samba, of course, the ballpark. And that's not called AT&T Stadium, but Oracle Ballpark, the new stadium, Chase Stadium is close by. So we're pretty central to everything. And it was, again, a place where people can get away. If they're stressed out at work, it's like a little getaway, like a little vacation spot is the way we put it. And we called it Reeves after Keanu Reeves, which is one of our favorite actors, and we loved his movies. So we called it Reeves. My partner actually was an extra in The Matrix, and so was my sister. So they were both in the same scene in The Matrix. And because of that, we're like, hey, this is perfect. So we call it Reeves. So that's the story of our bar, why we're here, and our name.
Awesome.
All right. My partner was going to come today, but I guess he has a kid, so he didn't show up. So I'm going to do this myself.
All right.
I'm the better bartender anyways, even though he's been in the business for 10 plus years. So to start with, we're going to make 2 drinks tonight. The first one is going to be an old fashioned, and the second one is going to be a peach fruit drink that we call Be My Maybe. And the first one, I'm just calling it the Continental, again, after themes in John Wick. I chose the old fashioned for a couple of different reasons. The first reason is it just teaches basic skills that When I first started bartending not that long ago, I drank a lot for many years. But in terms of actual bartending, I didn't really know that much. But some of the bartenders around this neighborhood taught me how to bartend. And old fashioned is one of the drinks that they taught me how to make in the beginning and all the skills needed to actually make an old fashioned. So I chose that as a drink. And the second one is one that we like to serve here because it is part of the theme of the bar where you are getting wet. You're going to maybe, a vacation spot. And whenever I go to a vacation spot, I like to drink fruity drinks. So I don't need a shot in beer. I want something fruity. I want something nice. I want something that I can just sip on all day for a while while I'm sitting by the pool or, just relaxing. So we're doing a fruity drink and we're doing a straight old fashioned. And I think if there's questions, I like to be interactive. So if you guys have questions, put on the chat. I'll try to answer the questions as we go through. This isn't a great production like Selena Chef. I don't know if you guys would watch that over the break or over the pandemic and being stuck at home, but that's a pretty fun show to watch and they have great production values. So we'll start. We're gonna start with the old fashioned. Like I said in the beginning, I chose old fashioned because there's a couple skills that you'll learn as you make an old fashioned. The skills are going to be muddling, they're going to be stirring, they're going to be the usage of ice and how you use ice, and then zesting. So 4 very important skills to have. And then on top of that, an old fashioned starts to teach you about flavor profiles and how you want to put different flavors in your drink, and you can make it your own. There is no right way to make an old fashioned. Everyone's going to have a different kind of, everyone has a different flavor profile. Everyone wants it a little bit different. So I'm going to go over kind of the variances and what you can do as you make your old fashioned. But the trick for the thing for bourbon and drinking these straight drinks is make it your own, okay? And when you're making old fashioned, you don't have to say, oh, you can't do that, you can't do this. Make it your own, okay? And when you make it your own, you should have a story, right? When you go to a bar, like part of going to the bar is you can hear people's stories. So for my old fashioned, the reason why I make it the way I do is because I used to actually do a lot of like hiking and mountain climbing. And when I did, if you guys have done multi-day hikes, it's very painful to carry a lot of stuff, but I always wanted a drink afterwards. So in my flask, I had some whiskey or bourbon, and I carried a chocolate bar, and I combined them two together for a really good treat after a long day hike. So it was one of my favorite things to do after my hikes, and then I just translated that into my old fashioned. So my old fashioned uses a lot of chocolate and actually bourbon, which you can use whiskey or bourbon for your old fashioned. All right. So the first part of old fashioned you start with is the sugar. I have here some brown sugar. I use brown sugar. I don't use white sugar, maybe because I don't want to get more processed. I know this is processed too, but I just feel it's a little healthier. But I also like the flavor. It's more mapley, so it does have a little bit better sweetness. So I try to use brown sugar. So you want to get 2 cubes of brown sugar, or 3, depending on how sweet you want your old fashioned to be. I'm gonna make it a little sweeter
Paul,
today.
If I don't have sugar cubes, I just literally have brown sugar. How much is a cube? Like a teaspoon? Half a teaspoon?
I would say it's go with half a teaspoon.
So 2 half teaspoons.
Can you see it? Is that
yeah?
A little bit?
So 2 cubes is like 2 half teaspoons.
Yeah, about that much.
So 3 sugar cubes?
2 or 3 sugar cubes. I use 3. I feel like a little sweeter today, so I'm going to make it with 3. You can use 2 or 3 sugar cubes. Okay. And the next thing I have is chocolate bitters. So you might have Angostura bitters, which is the more classical bitters. Angostura is perfectly fine. The reason why you want to use a bitter, it actually has herbal fragrances in a bitter. And so it makes it more herbal and also is bitter. That's why it's called bitter. So offsets the sweet flavor in your drink. And it's also going to mask some of the alcohol fireness in your drink as well. Even though it is alcohol, it's a lot sweeter. It's a lot more bitter and has an herbal texture. So you're going to like that in your drinks. So I usually put anywhere from 3 to 6 dashes of scrappy or of chocolate bitters. So I just want to make sure I get that into the sugar cube. So 3 or 6 healthy dashes.
Paul, have you ever tried to make your own bitters?
I have not. I make my own syrups, but I don't make my own bitters. Have you?
No, but I've been thinking about making, I think they're called shrubs. No, is it not shrubs? It's like
no, I don't know. I'm looking at Jeff shake his head up and down, so I assume.
Oh,
They're somewhat related, but yeah. I've had friends that have made shrub before, and you can use them as like an herbal flavor to a cocktail. They're not quite as strong or concentrated usually as bitters, but yeah, they can make some interesting cocktails. I don't know anybody who's tried to make their own bitters, but I think that would be a fun quarantine project.
All right, so next thing we're gonna do is muddle. So when you're muddling, I don't know if everyone has muddlers. If you don't have a muddler, you can always use a spoon. Use one side to break it up, and the other side kind of smash it around and to stir it to mix it. At this stage, though, so you see here, my sugar is drenched in my bitters, and I'm about ready to muddle. Some people here will add water or club soda, and the reason why they add water or club soda, it opens up the flavors a little bit more. I don't do so. I actually like, and it actually allows the flavors to blend with the drink a little bit easier when you start stirring the drink. So you can add club soda, or you can add water. The reason why I don't do it is I like the old fashioned to change flavors over time. So by the time you get to the end of the old fashioned that I make, it's going to be a lot sweeter. So it's a nice sweet aftertaste, so it doesn't blend as well. So if you want it to blend better in your drink, then I would use club soda, or splash club soda, a splash of water before you start muddling. Okay. You can choose to do it or not to do it. I choose not to do it. When you're muddling, hold your glass like this and put your muddle in between. So when you start hitting it, it doesn't splash all over your face or on customers if they're there. And for this one, we're just going to keep muddling it, basically just smashing it and blending it until there's some consistency. When you're muddling something like a mint or any kind of herb, let's say you're making mojito, you want to muddle it just to the point where you start smelling the flavor of the mint or the herb. Once you get to that point, stop muddling. If you do more than that, you're going to over muddle it.
Bringing up the muddler, what kind of tools do you recommend for like noob bartenders?
So a stir for sure, because if you have a stir, you actually don't need a shaker. You pretty much can stir anything. If you find a stir that has a weight in the back, like this stir does, when I first started here at this bar, we didn't have one, but it helps, and I'll show you the proper stirring method as part of doing this. And you can actually stir any drink. So you don't necessarily have to shake drinks. You can actually stir every drink that you make. Of course, shaking it is fun. It's great. But you can actually stir everything. So a stir, a strainer, which works both on a shaker or tins and on a pint glass. So I can put my strainer on my pint glass and strain that way as well. So this is a Hawthorne strainer. These are pretty cheap if you just go to any kind of store to buy. A muddler is always useful. Those are the things that I almost always use. A shaker and a shaker tin, a set of shaker tins are definitely a good buy. They're about 12 bucks. So with that, we pretty much make everything. There's measuring cups that you can get in jiggers, different size jiggers. For beginning, I would just say get this. I don't know where they put it. Our bartenders don't really they eyeball everything. So, but I like to use a jigger. And there's this measuring cup that it's about a 2-ounce measuring cup, and it's marked off. It's sold by the OXO brand. I don't even know how to pronounce that brand. You go to Bed Bath & Beyond, you can buy that, and then you can use that for almost every drink. So when I first started and I couldn't eyeball like more experienced bartenders, I would use that to measure out all my drinks. So I'd be super slow and they yell at me. So, all right. So now that we muddled, kind of consistent. I don't know if you guys can see this. Pretty consistent. It's broken down. I'm ready to go. Okay, now we're going to add ice. So the ice I like to use is block ice for this, or large ice cubes. You guys are scientists, so you'll know this better than me, but so there's surface area dilution that happens when you put ice with alcohol and water, all right? The more surface area, the more dilution and the more watered down drinks will get. So if you use a bigger ice cube, there's less surface area that touches, versus if I had one big ice cube at this size versus a bunch of small ice cubes, it's going to be touching a lot and it's going to dilute a lot faster. So with this, you can kind of control the flavor of the drink because there's going to be less dilution in the drink and less water going into the drink to water it down. So in the beginning, you're going to taste more alcohol. By the end of the drink, because I left the sugar in there, it's going to be a little bit sweeter. All right, so now I put my ice cube in there. Another cool thing about ice, I don't know if this is like a more of a fun fact about ice. Ice actually made bars popular. I don't know if you guys knew that. So ice was a novelty back in the like late 1800s or so, I think around then, whenever ice came out. So, and you couldn't get ice. You could just go to the store and buy ice. They come out in big trucks, and it's a pain. You know, refrigeration really was a very difficult thing to do during those times. So for you to enjoy and actually have a cold ice drink, you go to a bar. And so the bartenders and people back then that were making drinks really used ice to entice people to come into the bars. And then it was one of the stars of the show. It wasn't the alcohol, it was actually the ice that was the big star of the bars early on. So you get some nice ice, and then you can get a nice cool drink on a hot summer day, which you couldn't get anywhere else. Okay, so we're going to go to bourbons and bourbon section. I have a bourbon section here. This is definitely pared down from what we used to have because Josh and Jeff drank all of it. But I'm going to use a bourbon instead of a whiskey. Can anybody tell me the difference between a bourbon and a whiskey? Oh, are we do bullet? All right, I'll do bullet. Anybody?
Does it have something to do with the barrel that it's been in?
Kind of. Any other? So, okay, so all bourbons are whiskeys, but not all whiskeys are bourbons. Bourbon is a type of whiskey that has to be made and processed in a particular way to get the certification or classification of bourbon. It doesn't have to be made in Kentucky, even though almost all bourbon is made in Kentucky. But the big thing about bourbon is that it uses 51% corn in its mash for the distilling process, okay? So that makes it sweeter. So corn is actually sweeter than wheat or rye or any other grain that they use. And so it has to have at least 51% corn. I think some go up to about 60-ish%. And the more corn, the sweeter it's going to be. So bourbon is going to be naturally sweeter than your other alcohols or than your other kind of whiskeys. The other thing is it is about the cask. It's got to be in a white oak cask, and it's got to be put in a complete, just distilled, a clear white liquid going in, and then it's got to be aged for at least 2 years before it can be called bourbon.
And unlike every other alcohol, it has to be a fresh barrel. You can't reuse a barrel for this.
You can't reuse barrels.
And they toast the inside with fire right before they fill it.
And so
Or what happens if you reuse the barrel?
You can't call it bourbon.
It's not bourbon.
I mean, like, could I taste the difference? Or?
Yeah, I don't know. I think yes, because you're extracting all the flavors from the cask and the oak into the alcohol, and so it becomes part of the flavor profile of alcohol. If the flavors are gone, it's going to taste different. So a bourbon from an older cask, or a cask that's been used again for some bourbon is going to be a whiskey at that stage, is going to taste different than the initial bourbon. They do use those casks over. They'll make whiskey out of it. They'll ship it to Scotland to make scotch out of it. So they will use that cask over, but in order for it to be called bourbon, you can only use cask once. The last final fun fact of bourbon is it was the first federally regulated food product in the United States. So because at that time, bourbon was getting very popular, people made a lot of moonshine versions, bootleg versions of bourbon, and some people were dying, and they go, we need to regulate this because people are going blind, they're dying, they're shooting their neighbors, I don't know what they're doing, but let's regulate this so that actually, now it's a federally regulated product, and it has to match all this criteria before we call it bourbon. All right, so now that we have our bourbon and our little talk about bourbon, pick your favorite bourbon. You can also use whiskey too, so you don't have to use bourbon. I just want to use bourbon to be more classic. And we use Bullet. Bullet's easy to find everywhere. It's a good flavor taste. It's a little sweeter than other bourbons. Sometimes I like to use spicier bourbons, or a little less sweet, so a little bit more flavor, but I think Bullet's a great choice. So you put about 1.5 ounces to 2 ounces of bourbon in your cup.
I feel like I should have known all these fun facts. My grandpa was a chemist in Kentucky, and his job was to taste whiskey.
Oh man, that's a great job.
Yeah,
I'm really missing out on the family trait here.
How do I get that job?
Yeah.
I have no idea.
All right, so now we have our stir, and we're going to stir. So there's a proper way to hold your stir. It's almost like a pencil. I don't know if you guys can see how I'm holding my stir. Like a pencil is used this way, so it's a little bit different, but usually you hold the pencil this way, right? You put it down and you're going to hold it between your middle finger and your ring finger on your right hand. And then you're going to put your thumb between your index finger. Okay. And you notice that these grooves aren't for looks on the stir. Some people think they were. I thought they were. I see people just stirring like this. So if you see a bartender just stirring like this, they are probably working in a bar that moves pretty fast. So like a nightclub. But most people were taught to stir, or we were taught to stir by putting it in and then just let the glass move. So you're using kind of your wrist. I'm barely using my hand. I'm using my wrist. I'm stirring with the flat of the stir against the outside of the glass and just letting my wrist kind of do the stirring motion. If you guys can see that. And you want to hold your glass when you do this. One of the reasons why you want to hold your glass when you do this is right when the glass starts getting cold, it's done, right? Otherwise, it gets over diluted again, and it's going to change the initial flavor. So to be consistent with the flavor, you want to make sure that it dilutes to the proper temperature. Dilutes to the proper balance. And then that means you're going to control it by temperature. So the glass is cold, I am done. Okay, so I stop stirring. So that's going to be about 15 to 30 seconds, depending on how much ice you have and what ice you're using. All right. Questions about stirring? Stirring probably took me a lot. I used to just come to this bar before I bought it, and the bartenders here would just make me just stir. I just sit there and stir drinks for like a long time and practice stirring with ice and water. All right, so and another part that was hard for me to learn was zesting. Shaking is easy, but stirring and zesting was, for some reason, it was really hard for me. So we're gonna zest an orange. Now we're gonna add one more flavor to our drink. So we have our bitter, we have our herbs, we have the flavor of the alcohol and everything that comes with that flavor of the alcohol. We have our ice to maintain the balance between all of them and to get it cold so it's nice. Now we're gonna add the last component, which is our orange, which is a zest, a citrus. So to zest an orange, you just want to use the peel. You don't want to cut the orange and just throw an orange chunk in there. You want to use the peel of an orange or the outside of an orange that has a lot of flavor in there. So we're going to take the top and we're just going to cut a little piece off and just slice it through. So you're going to get a piece like this. Okay. If you don't have one, you can use a knife and you can cut just the skin of the orange with a knife. Not as pretty as when I do it that way, but I still have, actually, let me cut this better piece. You got an orange piece. All right. So we're going to use a prettier one. And then to zest it, you want to squeeze the orange peel like so. So we're pushing down and then just adding a little bit of flavor. If you do it right, and maybe not in this drink because there's a large piece of ice in there, you'll see the orange or the citrus juice go into the liquid and disperse the liquid a bit. So you're just going to push, you're going to squeeze it, and then you're going to take that and you're going to rub it around the rim. And the reason why you rub around the rim of the glass is so that when they taste it, they'll taste the citrus first and then taste the remainder part of the drink. And then you can choose to put the peel inside of the drink, or you can choose to put the peel outside of the drink. Some bars and some bartenders will actually just put on a toothpick and put it in there, and then your choice of what to do with that orange peel. I'm going to leave it out, kind of like the way it is without having it in there, because over time, unless you're drinking this and taking it as a shot, the orange starts seeping in, and you're going to get more orange flavor in your drink. So if you want to have more orange flavor and more citrus flavor in your drinks, just throw the peel in there and keep it in there. If you want to just have it initially, upon the initial taste, you just zest it, rub the rim. So you rub the rim, and then you're done. And then you put it aside.
Paul, do you ever try other kinds of citrus, or is it always orange?
Yes, I do, actually. So you talk about with an old fashioned or with other drinks?
Oh, yeah, just in general.
Yeah, we use lemons, limes, and then orange are the three most popular. So instead of just, you can actually squeeze it in there, but you get most of the oils, like the orange oils already, or the citrus oils in the drink just by zesting it. So you have to squeeze and have all the pulp in there. then you're good to go. So other things that you can do with your old fashioned, what I've seen people do, actually lemon's pretty good too. So if you wanted the lemon with the old fashioned, I like that sometimes. Instead of the orange flavor, I'll put a lemon in there. I also put a maraschino cherry or a cherry in there as well. So if you want a sweeter, it's not going to taste like full Manhattan, but you kind of get that Manhattan flavor in there by using a maraschino cherry. So I like that too. This one's already sweet enough with the sugars in there, so I don't try to sweeten any more with a cherry. But I have friends that like it with a cherry.
What's the difference between a Manhattan and old fashioned?
They still both use bourbons or whiskeys as the base liquor. A Manhattan will use vermouth versus we're using bitters in this. Actually, there's still bitters. There's Angostura bitters, there's vermouth, and then there's bourbon in a Manhattan. And you don't have vermouth in old fashioned.
Yeah, thanks.
Yeah. So with old fashioned, you can play with different flavors. I mean, I could taste the orange upon the initial taste. Now, when you taste it, you can taste all the different kind of flavors of your old fashioned. And can get sweetness from the brown sugar and the chocolate. And that's why I chose it as the first drink.
I've had an old fashioned, but instead of the orange at the end, I've had like a little pineapple chunk. And so it gives it kind of that sour tart flavor on top of the standard old fashioned.
Oh, nice.
Yeah, a bar in Austin, one of my favorite cocktail bars in Austin, does that, a pineapple old fashioned. It's one of my favorite drinks to do.
You know what I haven't tried, or what I was thinking about trying was the Lee Hing powder, like you're talking about Hawaii. I want to do a Lee Hing powder drink. That might be pretty nice with the old fashioned.
Interesting.
Hey. Someone else had a question?
Everything is good with pineapple. I mean, pineapple's one of the great things in the world.
Yeah, it's true.
Even pizza.
I'm on board with that.
Yes, on board with that.
I actually do like the ham pineapple pizza combo. All right, we're okay. So that's it with old fashioned. Good on that one. Cheers.
Yeah, cheers, everyone. This was cool, and we got a whole second drink to do at some point.
All right, we got another drink. All right, so the next drink that we're gonna do is more of a fruity drink. This is our Be My Baby drink, which is gonna use peaches, Saint Germain elderflower, and Saint Germain elderflower, and vodka and lime juice. So it's a little bit more complicated drink to make. You're gonna need more things to make this drink. But I like to use fresh fruit in our drinks at Reeves, just because, again, it feels more like you're going on a vacation. So I actually have frozen white peaches here. And the inspiration for this drink came from, my fiance came home one day and she had this boba tea, which was this lychee, white peach lychee boba tea. And I thought it was amazing. It was like one of the most amazing boba teas I've had. I don't really like boba tea all that much, but this one was like this fresh white peach. It was fresh lychee, and it was just an amazing drink. So when I had it, I'm like, I'm going to go to the bar and I'm going to try to make a drink just like this. So I went to the bar, and over the last couple of weeks, I started trying to make different drinks to get it. Not quite as good as that, but it was still pretty decent. So this is one of our more popular drinks here. It's limited here, and so I always sell out by the end of the night. But it's in this case, I'm using frozen peaches instead of fresh. And the difference between the two is fresh peaches, although good, is not going to be consistent. So if you buy frozen peaches, they're pretty consistent about how ripe it is before they freeze it. So you're going to get a more consistent flavor if you use frozen. Another benefit of this is that it's cold already going in once you blend it together, so your drink can be cold right off the bat. If you use fresh, I think it tastes good. It has that fresh taste, of course, but it's different. It could be different every time. I had people come in and go, oh, this doesn't taste the same as last week. I go, well, because I'm using different peaches. So depending on the types of peaches you get, depending on how ripe they are, it's going to be different. So in order for us to make our syrup, we're going to take some fresh peaches. And we're going to grab some fresh peaches here. Where's my little tongs? So I'm going to grab it. I'm going to put it into my Ninja blender.
How many peach slices?
In this case, I have about about 5 slices.
Okay.
You know what, I'm just going to blend all of it since I have it here. You don't need more than 5 slices. You're going to be using about 2 ounces of this. Then I have my simple syrup. I don't know if you guys had a chance to make simple syrup. The simple syrup is just water and sugar on low or medium heat until the sugar dissolves. And you can use 1 part peaches and 1 part simple syrup. So the way I calculate that is you just cover your peaches with your simple syrup and you should be good. So here's my peaches. You guys can see that. I'm just gonna cover this. That should be good to go. You see it? I know this is very precise measurements when I bartend. It's like Chinese cooking. All right. Got my Ninja. Put it over. Then I put it on the blender. Okay, so you want to blend it until it has, until it just basically becomes like, you know, syrup. There's still going to be some chunks in there. Sometimes when I blend it, there are chunks. In this case, because it's been frozen, there's going to be less chunks. If I want to do fresh, there's going to be more chunks. When it's frozen, less chunks. Maybe someone can explain that to me. All right, now we got our tins. If you don't have a tin, you can also use a pint glass. I don't know if people have shakers at home. If you don't have a shaker, you can just use a pint glass. And then I'll go through an alternate method with a pint glass that you can actually do and make this drink. So now I want to take about 2 ounces of my syrup and I want to put it into my tins. Actually, I don't need this. I'm just going to measure it. Pint glass. Okay. And then the next step is putting my elderflower. So I'm using Saint Germain. For those at home that aren't drinking because it's dry January and you guys want to use I think we suggested using the light Calpico lychee. You could try using that instead of using elderflower liqueur. And then there was nothing really substitute on the bourbon except non-alcoholic bourbon. So here we have some substitutes. So Saint Germain.
You can also sometimes find elderflower syrup. So you can, when you sort of, this is what I'm using for my simple syrup because I don't have Saint Germain. And this keeps in the fridge for months and months and months.
I might try to find some of that. So I do have, an elderflower is the best way to describe it is a lychee flavored kind of liqueur. Elderflower does have a flavor, but I always associate with lychee for some reason, and it smells amazing. It's great in drinks. I use it in our gimlets. So I use it in a bunch of different drinks. I really like elderflower. My partner doesn't like me using it that much because it's expensive. But I like to use it, so.
It's really nice on champagne too.
It's nice with almost everything. Like when I go to a bar and I see an elderflower drink there, I always order it.
That's what I was
My
going to
husband is British, and go ahead.
Go ahead, Genevieve.
I was just going to say my husband is British, and elderflower is just a very common thing in England.
Oh, really?
You know, yeah. If you go to a bar and you're not a drinker, you can just get an elderflower and soda, and it's basically this kind of stuff. I mean, you can use it's almost like a normal soda pop flavor.
Yeah, the flavor is just amazing. So we're only going to use about 3¼ ounces, so 0.75 ounces of elderflower. I use a jigger for that, and I poured it into my drink. And the next step is going to be the alcohol. If you aren't using alcohol today, you could basically use club soda. I make this with club soda for my girlfriend, because she sometimes doesn't want to drink when she comes to the bar and I'm working. So she just drinks this club soda with a peach drink. So the vodkas. So I know there's all this branding for vodka and it's expensive, but pretty much to be called a vodka, you just have to be flavorless. zero flavor profile and has to have alcohol in there, right? So it's the most neutral spirit you can get. If you drink vodka straight, maybe I would say, okay, go with like a, you know, like a higher end vodka. If you're just using it for a mixed drink, any vodka will do. I, you know, probably want something that's at least filtered a couple times, charcoal filtered. I'm not going to use a well, but well is perfectly fine for most mixed drinks. So don't waste your money on very high or expensive vodka. Most vodka is, like, by nature, vodka is supposed to be the most neutral alcohol you should buy and can buy. All right.
What's
in our
your
case,
favorite martini vodka?
if I have to drink vodka though, so I can't tell. I did taste this a long time ago with some coworkers where I can tell if you drink it straight, because martini is just almost all vodka, pure vodka, and you just shake it with a little bit of, depending on how you have it. I actually like Grey Goose or Kettle. So I actually can tell there's some flavor, and it's not really flavor. I just feel like there's less burn. So that alcohol burn is a little bit less, and you could taste just a tiny bit more with those. But this is like, you know, I was a vodka drinker for many years, and like many years. So that's after like 10+ years of drinking vodka. But most vodka doesn't have much flavor. Good vodka that's cheap out there is Stoli. So Stoli is great. I would use Stoli if you had it.
Paul, what do you think of Tito's vodka from Texas?
I'm using Tito's right now. Tito's is fine. I use it for a lot of mixed drinks.
Yeah.
I don't really, you know, like it's fine. Tito's getting a little pricier. I own a bar, right? So Tito's getting pricier than some of the other alcohols. But Stoli is just as good as Tito's, in my opinion. When you get higher, like Grey Goose, I think Grey Goose does have a little bit of different flavor, especially if you just drink vodka on the rocks. I don't know if you guys try that, but just drink it on the rocks, nothing, no lime or anything. You can kind of taste the different flavors. All right, so I'm going to use Tito's, 1.5 ounces of Tito's.
The Polak in me weeps about flavorless vodka. I did a vodka tour in Poland, and they made this comment that Americans do it like they distill it 4 or 5 times, and that's what takes out all the flavor. But there are tons of like Polish vodkas that are distilled once or twice and have tons of flavor.
I mean,
oh, that's
yeah. He brought some Polish vodka home.
Yeah, that's right. It's the only vodka I have in the house from my last trip to Poland.
We used to have, or currently have their team in Warsaw. So we've gone there a bunch and done a lot of the vodka tastings and brought home lots of samples.
Yeah, Jeff and I accidentally became vodka experts.
Yep.
I think, well, I don't know. Maybe it's because here the definition of vodka is it has to be flavorless, right? So it's got to have 0 flavor for being called. Maybe it's Polish spirits, but if you want it to be called vodka in the U.S.,
yeah,
it's got to have 0 flavor. That's the definition. So I could tell there's little different flavors of the vodkas, but again, if you're putting it into, like, if I'm putting peach and syrup and elderflower, it pretty much is going to drown out any faint flavor that the vodka may have, at least the U.S. type vodkas. All right, lime juice. We're going to put a little bit of lime juice in there. Where's that lime juice? I had lime juice earlier. So you're going to use about 1/2 ounce of lime juice. So 1/2 ounce for me is about a squirt. 1/2 ounce to 0.75 ounces of lime juice. Just going to put it in there.
How many ounces of lime juice would you say is like a lime slice? Or what?
Oh, not 0.75. not. So you probably want to use about
like half.
About half. I would say is usually when I like if I make a drink from fresh lime, it's about half a lime.
Sounds good.
Yeah, I'm getting about 1/2 ounce out of a little less than 1/2 ounce out of 1/2 a lime.
Yeah, if you squeeze it by your hand, you can get those lime squeezer. It gets you a little bit more. So yeah, it's gonna maybe a full lime then to get.
Yeah, thank you.
I know with these drinks, like part of the thing with lime is it takes away that fire, like that alcohol spirit firedness. I know people like to have shots in, a beer and you get, taste alcohol, you're mad, right? But for me, it's like when I'm making some of these drinks, like I want to eliminate the alcohol flavor and bring out the flavors of everything else. And you still have the buzz, right? So I'm actually trying to eliminate the alcohol flavor as much as possible for some of these drinks. So there's two types of styles, and that's why they have the old fashioned in here where you have alcohol flavor in this one, and you want to use whatever comes in alcohol versus this drink, which doesn't use, which basically alcohol gets eliminated or tries to eliminate it. So it just tastes like a nice, refreshing drink. All right, so I have my lime juice. I'm actually making 3 of them, and the reason I'm making 3 of them, I'll show you in a second. I just don't have anybody to drink it with, so I guess I'm drinking 4 drinks by myself here in the bar in about 30 minutes. So I'm making 3 drinks, and I'll show you because in case you don't have the tools, you want to use different ways of drinking this. So the last thing that we're going to put in is ice. Don't put the ice in yet, and the reason why I want to teach you guys how to shake. So once we're done with that, we're going to shake this drink. And when you shake a drink, you want to shake the drink where you're going to shake it to the point, and the reason why you shake it is to kind of blend the flavors together. So the ice smashing back and forth against it creates like this. Like if you wash your sheets at home and you put a tennis ball in your sheets, I don't know if people do that, or you try them, you put a tennis ball, it kind of, it actually helps. Scientists can tell me why it does this, but it helps, right? So there's more. You actually get more flavor into the drink by shaking it with ice because the ice collides against each other and I don't know, it causes explosions. In my brain, there's many explosions that happen. So you shake it and then it cools it down. And we don't want to put ice in first because if you put ice in first as you're preparing multiple drinks, and I'm giving this explanation, you're going to start bruising the drink. It's going to get over diluted. It's going to have too much water in the drink. So when we start shaking it, it's not going to taste the same. It's going to taste good. So I put in the ice last. And I want to explain how to shake. So when we shake, the things to note, when you shake, you want to make sure that you have a hard hit to seal the container against whatever you're shaking against. There were times, even myself, and I remember the last one I did of these Zoom things, I ended up spilling on myself because I used egg, and the egg actually exploded a little bit inside. And never shake club soda, right? So you can never shake anything carbonated. So if anybody tells you to shake something carbonated, just say no and walk away. So basically, when you got to make sure it seals, and then you shake it. You can shake it with 2 hands. So you seal it, make sure it hits. Shake it with 2 hands. So you can go like this. You can do the 2-hand method, and you can use the 1-hand method. If you use the 1-hand method, you want to make sure that you put at least 1 finger on the other tin so you can feel it move. If it starts to move, you got to stop shaking it and reseal it. And it happens. So it does happen. So a 2-hand method is the safest one, and you can get fancy if you wanted to with this. I learned the 1-hand method. If you have a Boston shaker, I see a Boston shaker over there. You just cap it, make sure the cap is tight, and then you just shake it this way.
What makes something a Boston shaker?
Oh, so this is, I forgot the name of this shaker. But this shaker, you're using a shaker, you have a shaker cup, a shaker tin. A Boston shaker has a cap on top of it. Okay. So I don't know if you guys can see it in other people's Zooms. That's a Boston shaker. So you put a cap on it and then you just make sure you hold the top of the cap. And we're also taught not to shake 2 people because when there are explosions, so for some reason, it can go right into the face of somebody. Or if it comes from and shake. So we're always, if you see bartenders shaking to you like this, then that's not a good sign. And they should be shaking this to the back. If they shake it to the front, they can spray all over someone else. And that's another reason why we wear black as well. Black is because we get water on us all the time. So, okay, so that's how so when you shake, you want to shake it vigorously, and you want to make sure, put some effort into that shake. You want to make sure those little mini explosions happen inside the glass, all that magic starts to happen. And then the other thing to think about when you shake too is, when do you stop shaking? So you can't just keep going forever. It's not a cocktail like the movies and you're shaking for 2 hours. You want to stop shaking when you start seeing a little bit of condensation on the outside. So right when it gets to the point where there's some liquid and condensation, you're done. right? So the drink is done. You don't need to shake that anymore. Also, if you overshake, first you're going to bruise the drink, which means that you're going to overwater it and overdilute it. And second, it's going to cause a vacuum. So if you ever have like, and maybe one of you guys explain this to me, like this vacuum gets formed, which is almost impossible to separate, or it's very, very, very difficult to separate. And then you're sitting there looking like a fool trying to get the glass to come out. So shake it just to the point of condensation, and then you're done shaking it. All right, that makes questions on the shaker. Okay, one more thing is I'm going to serve this drink in two ways. One is up, where I'm not using any ice. Another way is just with all the ice and everything else. And then finally, I'm just going to make it one time with a pint glass without a shaker and stirring it, so you can see how that works, which works perfectly fine. So I'm using a coupe glass here. If you want to chill a glass really quickly, just pour some ice into the glass like this, and then put some water here. So that way my glass will stay chilled. I do that before I make the drink, so that when I'm making the drink and shaking all that stuff, this glass is starting to get chilled on the side. And so when the person gets a drink, they can enjoy it and have a nice chilled drink. Okay, now it's time for our ice. So we got our ice. And when you want to put ice in, you want to put a healthy amount of ice. So don't skimp on the ice. I fill one of these shaker tins about 8/10, 9/10 to the top. I want to do it full, but like a good scoop. So not enough on that first scoop. So I have a good, you guys can see that. So I have a good amount of ice in there. All right. Watch me explode. And I'm popping that, seal it, and ready to shake. So I got my one finger on here to make sure that. So there's a couple ways you can shake back and forth. The way that some people say is you do a cyclone motion. So you're trying to make a mini tornado inside. And this is already done. This is way done. So then I'm going to take this out, and I'm just going to pour this right into the glass. So my wine glass, I'm going to pour it right into the glass. So ice and everything. When I first started making this drink and used fresh ice, what happened was it got too diluted over time. So now that I've already diluted a lot of ice in there, I'm just going to use that same ice, put it in there. If I had fresh ice, it will re-dilute, have more water over time, so it doesn't taste as good. Final two things for this drink is the fun straw and an umbrella.
Question, doesn't the used ice have a lower surface area to volume ratio? Like, wouldn't that dilute faster then?
Yes, but a lot of people will always, for most people that come to this drink, they're going to be sipping this for a good period of time. And the reason why I know, and so they're going to put it down, they're going to toss, they're going to sip. It has more, but it has less ice, right? So if you put fresh ice over time, all that new ice is going to melt into the drink. So effectively using like 1.5 ice versus just 1 ice. And then I noticed because a lot of people just left their drinks, and at the end, and even when I tasted it myself at the end, it just didn't have any flavor left. It was just like, you know how when you have a drink at the very, very, very end, there's just like absolutely zero flavor. So I try to at least have something where even in the last sip, there's still some kind of flavor, so you're just not just tossing it out. All right, so that's a pretty sweet drink. You probably can taste very little alcohol in that drink, so some people order that one. You definitely need to have, if you feel like it's too sweet, add a little bit more lime juice, right? So if you think that drink is too sweet right now, lime juice helps cut through that sweetness. So another way to serve this is up. So instead I use ice. If you're worried about the ice and you don't want to see it diluted, you can always serve a drink up, which is then, so we prep this ahead of time. So I have my glass, tossed out that initial ice, shake it. Condensation started to form, good. Take my strainer. You guys can see that. So I take my strainer, and then I can just strain it now.
And Josh is carefully working the umbrella.
Got the umbrella in there? And so this one is served neat. So this one isn't going, this one is served up. So it's not going to dilute with any ice. So it'll have the same flavor all the way through. And then having a chilled glass keeps it cold for a longer period of time. And that's why you also have the stem. So you're holding it by the stem. So your hand isn't transferring any heat into the glass to change the flavor as well. All right, so that's another way of doing that. Okay, and then now if you had just a pint glass, same thing that you do with a pint glass, you put the ice in the pint glass, and you just stir. Get a stir. Feel the glass, my hand is touching the glass to make sure I'm stirring to the point where it takes longer to do, of course, but now it's cold. All right, now it's cold and it's ready to serve. So either way works.
That Instagram photo.
Gotta. I mean, come on, right? Gotta get all in there too. There we go.
Post it. Tag AAS237.
That's right.
Cheers. How do you guys like? How does this last one taste?
Well, that's very sweet.
It tastes like it doesn't have a shot and a half of vodka in it.
Yeah.
Delicious.
If it's too sweet, I suggest I put a little bit more lime in there, or add 1.5 ounces of the syrup instead of a full 2 ounces of syrup. I think it just depends on what you like in terms of the sweetness. I know it tastes less sweet as ice melts. All right. Oh, cherry bitters.
Just for the record, we don't have any vodka in the house. I made this with gin. It's delicious.
Nice.
Oh, nice.
So.
Yeah, if it's not a super pine needle-y gin, I could.
No, it's just Tanqueray. Right?
Oh yeah.
Vanilla gin.
Yeah, a more neutral gin. Sure. Yeah, I've got my giant Bombay Sapphire up here. Yeah.
Yeah.
Yeah, gin works.
We are definitely a gin household, not a vodka household.
When I make my gimlets with gin, I actually use elderflower in there. So another drink that we do is an elderflower gimlet, which is pretty much the same thing as I just made, except without the peach. So elderflower, gin, and lime juice, and then that's a elderflower gimlet.
That is my favorite drink at Reeves Bar. Paul has made that for me since it opened, basically, because I was like, oh, elderflower and gin, yeah, I'm on board, and that's my go-to there.
Yeah, that goes down too easy. Even my sister does. My sister used to work with us too, and she doesn't drink at all. That's the one thing she actually will order and want to drink, because it doesn't taste like alcohol at all.
Yeah, but those are dangerous.
Yes, indeed.
Definitely dangerous. Definitely dangerous.
Well, the next
Paul, what is it like to own a bar?
When I had
what's awesome
right
about
now,
it and what sucks about it?
The best part is, actually the most awesome part about it was being part of kind of this community here. I lived in Soma in this area for about 10, on and off for over 10 years.
Where in Soma are you guys?
We're next to the train station, so about a block away from the train station. And being part of the community and all the other service industry was amazing. We're the service industry bar, and that's one of the reasons why I was able to learn a lot faster or more, was because all the other bartenders and everybody drank here, and they would tell me what I did wrong pretty much every time I bartended. Or actually, they just teach me tips and correct me and really help me. And so being part of that industry and being part of the community too, because we have a lot of regulars, ours is more regular bar, was great. I think that was the best part. Was I definitely feel like I'm part of this community because of having a bar, right? What sucks about it, can't really. I mean, if it was non-COVID time when we had it, I don't.
Yeah. Like right now, it's different, but.
Yeah, I mean, it was just a lot of long hours, but even then, it was like it's rewarding. I mean, I would be here on Saturday or Fridays till 3 or 4 a.m. So I'd work my normal job with these guys, and then I'd go work the bar, and so I only had one day of rest, which is Sunday. So there was a lot of long hours in the beginning. Regulations, I guess, but I think that's all businesses have regulations. So you got all these extra taxes and all these regulations that you had to pay. But I can't really think of anything that really sucked about it. Like, I don't think there was anything that was bad.
I'm guessing you're an extrovert.
I don't know if I'm an extrovert. These guys are better judges of it. But it's nice to go to a place, and I always wanted a bar where people aren't going to be very judgy, right? And since I'm in tech too, like I feel like a lot of bars around here were more judgy towards tech and that type of stuff. And I wanted to create a place that wasn't that way. Like everybody could come in and just have a drink. So yeah, I don't really think there's anything too bad about it.
I mean, one challenge that you and I had talked about before COVID was like ways to distinguish the bar, right? Like specialty nights of like, you know, a lot of bars in San Francisco do trivia nights or, you know, host astronomy or science education or public engagement events, and, you know, how to distinguish yourself from all the other bars that do cool cocktails and want to be chill and welcoming to tech people, but, you know, have their own thing.
Yeah. I think the challenge of getting our name out there was one of the big things that we still continue to struggle with. I'm sure when this is all over, we'll still have that same problem. But I think it's something that we were overcoming. You know, like it was we were starting to make some headway into that. I would say, like, I know I'm optimistic, but in March, you know, we definitely had a lot of traction in March, and you know, a lot of parties were being booked here, and a lot of people wanted to do private things here. So that was, you know, that was good. Another thing here challenging is the real estate, as you guys know. So hopefully after all this is done, like real estate price and owning a bar, and actually the expenses of owning a bar will be a little bit lower than before.
Is your rent dropping? Should be.
Yeah, we're negotiating. Negotiating. You know, it's the landlord. You know, is kind of day by day with the landlord on what he feels like he wants to do. But yeah, we're trying to keep a lower rent. But I like it. I think if you ever wanted to own a bar, and you know, like it takes a lot of time though. I think that's the one thing. It will take a lot of time. It's not something where it's not ownership, you know, and you're just going to hire all these bar managers and bartenders and have it run. You got to be there. You got to, like, you know, be passionate about it. You want to talk, you know, you want to be able, if you're an introvert, then probably not, because you probably do want to talk to people and, you know, get regulars and have, and take, not just, you want to make sure that, you know, like you have an interest in their life, right? And that's the reason why they come and they continue to come. So I liked it. I like being part of this community. It was a really good experience. Those months that we were fully open. But even afterwards, I remember during summer when we first opened, and I remember people were coming in and they were just so thankful. One of the first parties that we had, it was a private party for my bartender and her friends, and people were at home for a couple months now, and they came in and they were just thanking me, and they're, you know, I wasn't supposed to shake their hand, but they're shaking my hand, and they're going like, you know, so thankful for you to open the bar and to take this. I know it was a risk. We're not supposed to do it. But to do this because we've been stuck at home the whole time. We haven't had any social interaction. It's such a part of our lives. And we appreciate, you know, you opening and, you know, being able to come. And we had a girl cry when they came into the bar because they haven't been outside, and they just, you know, they were sitting here and they were just able to actually socialize a bit, which, you know, before they're just at home. So there was those times where I thought, like, you know, like that's what a bar is supposed to be. It's supposed to be part of the community and bring people together.
It's really meaningful. I mean, I haven't been to a bar or eaten in a restaurant in almost a year now, and everything's closed. You know, I mean, I live in Santa Cruz, so I don't know if what's happening here is exactly the same as what's happening up in the city, but everything's been closed for months.
Yeah, even the bar's never open.
They'll open. What'd you say?
The bar's never opened at all, even a small portion.
They might have, but I wasn't gonna go. So.
Yeah. What we've been able to do is have private parties for people and try to keep it under 15 people. So if someone wanted to have, like I remember my friend, they're about to give birth, or his cousin was about to give birth, or and they wanted to do a celebration, and they really haven't seen each other because they're all family, and they wanted to come to an area where they can celebrate and just drink. I opened it up for them for that. So we've done a couple private events where people, they all knew each other. I know it's not the best thing we could have done, but I think some people needed it, and it was very helpful.
People get to choose. I mean, so I have an 8-year-old son, and we're part of a homeschooling pod because distance learning, the schools have been closed since March here, and distance learning does not work very well for elementary school kids. But, in order to participate in the pod, we sort of all have to sign on to a certain, agreements about what else we're going to do. So we have to be maybe even more careful than we might choose to be as individuals.
Oh, I see.
Because if everybody is like a little,
Yeah, because they have to interact with each other.
Once you have a group, if everybody just like sort of slides a little bit, then suddenly there's a lot of exposure. So.
Well, look, to put together this, this entire Splinter session, Josh and I formed a pod for the only reason is to put together this Splinter session. So not to hang out because our partners are also friends and go on a trip to Tahoe together, but just
not remotely for that reason at all, ever.
No, sacrifices we make for
the sacrifices happens. Thank you.
You ever think about buying a bar or owning a bar? Right now is a good time to buy a bar.
Yeah, my husband
really good,
good
prices.
We sometimes talk about opening a pub because, as I said, he's English. Pubs are a way of life in England, and they're the U.S. equivalent is not quite the same. So we sometimes talk about that. He actually got involved in a startup that was a liquor business, making sort of bespoke flavored vodkas. You could sort of dial in your own combination of flavors. So you're talking about how vodka is supposed to be flavorless. I'm like, most of it's literally ethanol and water, right? And the question is like, what tap water do you mix it with, right? And the mineral flavors come from, are you using like Santa Cruz tap water or San Jose tap water or bottled water?
That's all it's supposed to be.
But they literally, it was like, he's like, oh, you want it to taste like Grey Goose? Okay, I'll mix you, I'll add tiny little, flavor additives that make it taste like Grey Goose. Oh, you want it to taste like Stoli? We can make it taste like Stoli. But so, yeah, so we have a pretty, he can't drink wine or beer, it gives him headaches. So we drink a lot of cocktails. And it's a lot of fun.
Yeah.
And I don't know, I think, I really like to cook. So if we opened a pub, he'd be like, he's the extrovert. He'd be front of the house, running the bar, making drinks, and I would be running the kitchen.
I fully support this, Genevieve.
I think you should do it. A lot of places open now.
Yeah, I think we're not quite there. I think we might have to get our kid launched, at least in sort of high school level right now. So he just started a job at Apple back in May. So he also has one of our speakers was saying that, I think it was Taka was saying he'd never met anyone he works with.
Yeah.
My husband also has never met anyone, and none of the people he manages, none of the people like on his team, he interviewed remote, he works remote.
Yeah, Josh is in the same position, I believe. He hasn't met anybody that he works with and interviewed totally remote, right?
Yes, that's correct. Haven't met any of them yet. It's weird.
It's the new world.
Mm-hmm.
Do you work Do you work with Rich Chu, Josh?
I'm sorry, what?
Do you work with Rich Chu?
Not like I'm probably gonna try to get involved with Rich. He's our head of marketing, and I think there's some marketing stuff. Data science traditionally hasn't done anything with them yet. We've been mostly focused on trust and safety and anti-abuse. But yeah, we'll probably break into that. Yeah, I have experience managing. We were just talking about Poland. Hiring and managing a Polish team, but at least then I could fly those people out. I could fly out there to see them. Here, even though everyone on the team's Bay Area, it still feels more alone, remote, distant than when the team was in Warsaw. But it's just normal for now.
As we're going through energy. Go ahead.
I think the flip side of it is that at least my experience has been that we're getting to see people being a little more human because everybody's working out of their home. People can't I feel like historically, it's almost, you sort of have to hide the fact that you have a life in the workplace, right? You hide if you have children, you sort of don't talk about that. You hide that. Like if you're doing caring for somebody else or whatever your other responsibilities are, you try to pretend they don't exist when you're at work. And COVID has made that impossible because everybody's walking around the room. So I'll be on the phone on a Zoom call with clients, and my son and the kid in his homeschooling pod will be buzzing around in the background. And I can't hide the fact that I have an 8-year-old, and that there's chunks of time where I'm not available because I'm teaching 3rd grade, which is not what I wanted out of my life. I did not sign up to be a 3rd grade teacher. But it just, I feel like because everybody's in the same boat one way or another, there's tolerance for it. Yeah, and there's a little bit of a sense of oh, we're all people and we have lives and we have other things that matter in our lives. And that's okay. Maybe that's even a good thing.
Yeah, at least where I am at Samba, I feel that being in a very privileged space without having many other responsibilities, maybe I'm speaking out of turn, but I don't feel that people had to really hide that. But I think that there is a greater appreciation for that, right? One of the people I work closely with, another data scientist, has a 2.5-year-old. Everybody knew it. She did her thing and, took the parental leave, and that was great. And had to take time off various times, and that's understandable. But then her and her husband work full-time remote, and they have a nanny, and they're privileged enough to have that, and that's great. But then the nanny came down with COVID, and so they all got tested. Then they didn't have a nanny for multiple weeks, and it was well, Tuesday and Thursday is my day to just watch Sierra and make sure she doesn't jump off a cliff. And I'm oh, okay. Yep. Let me know if you want to shift our meeting.
Yep.
It's now everyone's family and personal life has become their office mates, so it's hard to separate those.
Yeah, Taka was talking about this. I really like the way he phrased it, that we're all living at work. We're not working from home, right? There's a distinction of how you phrase that and how, the job has so much influence over your personal life these days. But there are good companies out there that care about that and take that into account, which a lot of people recognize from Taka and Genevieve's talk, and I think a lot of the companies that we represent. So that's something.
And as much as I hate the pandemic, I feel like people and companies are going to have to adapt to this and make the concept of working more human focused. You have a doctor's appointment, just go. You don't have to ask for permission or sign out. Just go do it.
One thing I think. Go ahead.
I definitely think it's changed the nature of work. That's why, in the area, I don't think a lot of these companies are going to come back to the same way they worked before, because it was already kind of this, especially with all the communication tools that we have today, there was already this progression to where you can actually work at your time, in your space, wherever that could be. But this really forced that to happen and forced companies to adapt to and utilize these tools to be able to do so. So I don't think this is it will change, but even from my finance head speaking, even from a financial viewpoint, this is much more cost effective for businesses in the long run too.
Right. Why pay corporate rents in downtown San Francisco for a giant fancy office where every single person has a desk and spends an hour and a half or 2 hours a day commuting just to get to work, right? Better to have that time of them working productively, and I don't know, you need a bunch of you need meeting rooms to use periodically, especially for technical people, right?
Maybe
consulting. Oh, go ahead.
Well, speaking of work-life balance and personal lives, I have to run off to go pick up my dog from doggy daycare. So it was a lot of fun. So.
What, you're doing doggy daycare? Aren't you at home?
Yeah, I don't do it that often, but I did it today because I knew I'd be back-to-back meetings all day. And
He's a relatively young dog, so it's understandable.
yes,
Like
she's very rambunctious and
It's like having a toddler.
Daisy is
Yeah.
lovely.
Yep. All right. Thank y'all.
All
See
right,
y'all.
it's good seeing you, Josh.
Bye.
Yeah, I mean, I'm going through the interview process now, and I'm always used to interviewing in person, and now interviewing on the Zoom calls only. I know what to do, but it's just not the same. It's not the same the same impact. But we'll see.
Yeah, the bandwidth of communication is narrower.
Yeah. It's like you don't interact. There's a way, there's some things about physical or just being face to face. There's some interaction aspects. But I think for work-wise, technical work or even most work that's more routine, you can probably get it done through just these types of conversations.
I mean, I think one of the biggest problems with technical work is getting people to just fuck off and leave you alone for a big enough block of time that you could actually get something done.
Oh yeah,
right?
that's always.
So I think the sort of work from home is actually great for most technical people because it just when the interruption rate dials down because you don't have people talking around you in your open plan office and you don't have people interrupting you with questions, it actually makes it easier in some ways to block out chunks of time where you're just unavailable, and that's what you have to do to get stuff done.
That's why we tried to implement. Well, this is what I might say. We implemented the no meeting Wednesdays or no meetings for a day or something. So you can't schedule meetings on this day with anyone, so that people actually get work done during this time.
I mean, it repeatedly fails miserably because people are like, oh, well, everybody's free on Thursday, so let's.
Yeah, everybody's free that day, so.
That's the point. This is the catch-22 problem. Yeah. So yeah, I've been annoyed by that personally, but yeah. Interviewing for technical role or interviewing either side of the interview for a technical role virtually is difficult because we ask a lot of whiteboard-based questions, right?
Right.
Oh yeah.
So there are apps, we've tried a few, they work okay, but it's not the same as hey, here's a whiteboard marker, draw a graph of something, and then I edit your graph by literally wiping my fingers across it and drawing something else and saying explain what happened, right?
So yeah. Also, yeah, there's with collaborative thinking.
Yeah.
It's a very dynamic process, and it's also one where very subtle social signals matter a lot because it's really easy for it to turn negative.
Yep.
Right. So having making it feel like this positive reinforcing collaboration takes quite a lot of effort, even in person. And I think it just becomes that much harder to give any kind of critical feedback remotely, right? Because in person, if you're giving critical feedback or you're having a negative interaction, you can soften it in all kinds of physical ways. And most of those tools disappear when you're trying to do it over Zoom.
Yeah, leading over remotely is especially for you said, critical feedback is harder because you can't take their cues and then you can't initiate different cues to kind of offset what they're trying to what they're feeling. So it makes it a lot harder over Zoom because they could just you don't know what they're doing with their hands, you don't know how they're shifting their feet or they're fidgeting in some way. So
right.
You can't work. I mean, you can't really rely on eye contact. I mean, I try to look at the camera when I'm on a Zoom call, but I'm looking at the chat today.
You can be looking at yourself.
All over the place, right?
That's the worst. I actually hate video calls because I find it so distracting. I'm like, oh my God, my hair is a mess or whatever. Yeah. It's so hard to not even just look at yourself. I usually have to hide the picture of me so I can at least focus on whoever it is I'm talking to. But I don't know. I in some ways prefer audio only. I find it easier to focus. I find the video very distracting.
Yeah, especially with multiple people because you're trying to your eyes are going all 5 or 6 people
I've been
at
scanning the bar behind you trying to be how many of these bottles can I identify from a distance where I can't read them?
I used to play that game at bars all the time. How many of those have I drank?
Yeah.
Did I get through all those? That's a fun bar game. Did I drink all those? Yeah, I've had almost all of these. Unfortunately. But anyway, well, thank you guys for coming to this session. It's later. If you guys are ever like in the Bay Area, want to stop by the bar, just, send me an email and then I'll come by because I got nothing else to do right now. So I'll come by, open up the bar, and it can be, talk about drinks all day.
Give Yelp reviews. Reeves is on Yelp. Check it out.
I was going to say, I've never been to your bar, but I trust that you can make drinks well, so I'm going to give you 5 stars on Google Maps.
Excellent. Excellent.
Thank you.
Thank you so much, Paul.
It's kind of fun because it's kind of like the first bar I've been to because I actually turned 21 over COVID.
Oh my
God. Oh, no.
Quite an adventure. So I haven't gotten to go to any bars yet. So this has been fun.
Wow.
Where are you from?
I'm from Boulder, Colorado.
Oh, okay.
Yeah, I'm an undergraduate at CU.
Oh, so you haven't gone to any bars, huh? I'm surprised that the undergrads.
I know.
Wow.
And Boulder's been pretty strict because it's quite like a liberal city, so everything is closed still.
You work with or have taken classes from Professor Comerford?
I have not.
Okay, she overlapped with me in grad school at Berkeley, and I visited out there 3 years ago, I would say, and gave a talk about data science and the transition from academia.
Oh,
and
cool.
Very well received. The Denver Boulder area is definitely a tech hotbed. Lots of good data related tech jobs out there as well. So yeah, I spoke there and at University of Denver, where Jennifer Hoffman, a friend of mine.
Did you like Boulder or Denver more?
I literally spent 36 hours on the ground there. I gave 2 talks. I had a couple.
I like Boulder more.
And I saw the Frozen musical when it was in previews before it went to Broadway. So that was my entire trip. So
That's awesome.
I feel I got a pretty skewed view of both Denver and Boulder, but I had a blast. I got to meet a lot of cool people and give a couple of fun talks and see a not good Disney musical, even though I love Disney. So that was a fun trip.
That's awesome. Yeah, I love Boulder. I grew up here.
Oh, nice.
Yeah, I'm hoping to pursue a PhD in data science, but currently I'm studying astrophysics. That's kind of my transition.
It's really easy to do. My colleague did his in machine learning, applied to astronomical catalogs and stuff. So
yes,
a lot of that.
I this will change eventually, and I'm sure Genevieve has thoughts as well. But I am incredibly skeptical of anything that says PhD data science because it's not a thing. I am incredibly excited when it says PhD astrophysics and their resume or their publications or their thesis title is, Bayesian classification of an unlabeled galaxy morphology photometry set, right? Something like that is oh, that's where you should apply that ML algorithm to get something out of a huge data set that humans couldn't do on their own, that you couldn't do heuristically, and then you're going to get some astronomy science. That is awesome.
Yeah,
so
I'm gonna second that in the sense that when I'm hiring, I'm always looking for people who have actually worked with real data, because so someone who's an expert in machine learning algorithms, that's maybe the 10th hire on a team, right? After you've done everything else, because the problem is never that you need sexier algorithms. I mean, I don't know, maybe at Google where they have all the data.
I was going to say, if you're at one of the FANG companies and you're trying to move the needle 0.1%, fine.
Right. But if you are a small to medium sized company, your problem is not that you need the most sophisticated, deepest neural nets that have ever been seen and you need an expert in that. The problem is that your data are for shit and you need someone who understands the fact that data is for shit and that and knows how to deal with that, knows how to figure out how to ask the right questions, knows how to figure out how to find better data. So I've hired people who have backgrounds in astrophysics and bioinformatics and statistics, and I'm sort of more interested in people who have taken these tools and applied them to some actual problem in some actual field, because it's not about the tools, it's about how intelligently you're able to use them.
Yeah,
so I think I
agree.
A PhD in data science didn't exist 5 years ago, right? So it's a new thing. I think it would depend on the program. I would definitely want to see a program that was very applied. So I think the closest equivalent I can come up with is when I was an undergraduate at Harvard, and they had an applied math department. And this was in, the late 1990s, because I'm old. And you could not major in applied math. You majored in applied math economics, or applied math physics, or applied math computer science. You took applied math and you applied it to something. And that's how I feel about data science.
That's a good way to put it. I like that.
I'm looking for data science applied to something, and I don't care what the something is, because all of that stuff is transferable. But I want you to have worked on real problems.
Definitely, yeah. So you would suggest like maybe getting a PhD, not in data science, or just if it's like very applied to a problem, or better like astrophysics with a data science.
If I were an undergraduate right now looking at PhD programs and I was interested in data science and using sophisticated modeling tools on real problems, I would probably go for bioinformatics. I think bioscience is poised on the edge of an enormous explosion. And I think a lot of the most exciting things that happen in the next 10 to 20 years are going to be happening in bioscience.
Yeah.
Not my field. I'm not there, but I think that stuff is super exciting. And I think that particularly anything dealing with like genetics data, because it's huge data and really hard. Like, I think those people make great data scientists, and I also think there's going to be a huge amount of demand.
Yeah, if that's a topic you're interested in, health data science is growing even faster than generic data science. I don't like the sight of blood, hate all of biology, never want to do that. I have friends that are great and interested in that, and good. They should go work at all those health data science companies.
Yeah.
But I always liked physics and astronomy. If I had to do it over again with what I know now, I would still do an astro PhD, because I thought maybe I would want to be a professor. Maybe I would want to do public engagement or outreach, which I did actually apply and almost get a couple of those kinds of jobs at observatories and museums. But then I also was interested in the big data side of things, and that's where I ended up. But it was definitely through, like Genevieve was saying, the application of programming and big data or data principles to the field of astronomy, because I liked that. I thought that was an interesting place to apply that.
Yeah,
data science is just a tool.
Yeah, it's wonderful to know, because I love like big data and I would love to know more about it. But also I've like wavered a lot between, I know I want my PhD, but like what to get it in if I know that's what I want to do later.
Were we speaking on Slack earlier? I was talking to somebody on Slack earlier about this exact thing, that they were very convinced they wanted to do a PhD specifically in astronomy. So maybe it wasn't you. I was talking to a bunch of people today, but they were like, they were asking like, should I take an internship as a data scientist later in grad school? I was like, well, if you want to go into data science, just go into data science. Don't bother with a PhD. And they said specifically they wanted to get a PhD in physics, but they were interested in other potential outcomes other than professor. And I said, okay, that's great. Go do, they had gotten into grad school or just starting grad school, I believe. And I said, go do that. But while you're doing grad school, build up these skills that we've talked about all day of using GitHub, using Python or R, publishing your work online and talking to people who are non-technical about it, those skills that will be absolutely applicable if you want to be a professor or a postdoc and in, a data science career.
Yeah, actually,
let me be very clear about this. Do a PhD because you want to do a PhD. Do not do a PhD because it's the step on a path to anything, because it is not the fast track to anything, and anywhere you want to go, there are other ways to get there. And it is 5, 6, maybe even more years of your life.
Yeah.
And if you spend them, if you are slogging through, and it's hard and it's a grind, and there are times when it's really fun and exciting, but they are thin on the ground and you spend a huge amount of time just grinding along. And if you are doing it because you love that and because you want the opportunity in your life to just tune out the outside world and go super deep on something and really understand it for real all the way down, do a PhD. That's why you're doing it, because it's a sort of once in a lifetime opportunity. If you're doing it in service of some other goal and you're like, well, I think this would be good for me, you're not going to finish, because it's just, it's too long and too irrelevant in some ways. So you do it because it's a thing that you're excited about, because you want to go that deep and because you enjoy it. and enjoy the process. And then you can do whatever. And if you decide you want to stay in academia, great, you can pursue that. And if you decide you don't want to be in academia, great, there are choices there. But you don't do a PhD as a qualification to get to, you know, some other place. You do it because it's a thing that you are excited to do.
Definitely. I think I do want a PhD. I think I've always wanted that like extra learning step, if that makes sense.
The other secret is that you can also do it for a master's degree. And you can't go in just wanting a master's. You have to convince yourself and them that you want a PhD, because then they'll fund you. But if you get in there and you do a year or two of it and you're not loving it, leave with the master's and move on with your life.
Definitely. Yeah, my other thing is I kind of want to live in Britain for a while, but they have it split. They do like master's and then PhD. So I think I'll probably end up hoping I would do a master's there first, and then if I really liked it, move on to PhD.
Yeah, it's very difficult to do a British PhD coming straight out of a US undergraduate, because you haven't done enough specialized work in a specific subfield, right? The US undergraduate degree is a more generalized degree, and a British PhD starts immediately with research. So an American PhD, you basically do 2 years, that's a master's, and then you do a PhD. And in Britain, because they specialize much earlier, they actually start specializing in high school. And by the time they get to college, they've applied in a single field and they've studied just that field. There's no distribution requirements. There's no electives. You study your one thing.
Mm-hmm.
So then you're in some ways more prepared to go into a PhD, and the PhDs are super short.
Definitely. So
I wouldn't try to go straight into a British PhD coming out of a US undergrad.
Yeah, get a master's first.
I have to leave, but thanks everyone. Today was tremendously helpful, and I'm going to join the Facebook group, and if there's any other events this week I'll join.
Yeah, there's a Beyond the Academy, which we probably should have mentioned.
Oh, okay. I don't know if it was like the same splinter group, but yeah.
It's there's like a panel that's on non-academic careers, but they seem to only be on education and in public engagement. But then later that day, and I want to say it's Thursday, it's on our ATDS website. Later that day, there's going to be like breakout Zoom rooms within the Career Center. People. So it'll probably be a bunch of the speakers and organizers from today and various other careers as well. But I'll put that in our Splinter channel as well.
Jeff, is anyone talking about careers in aerospace or places like RAND? Because that's another path that's super different from what we're talking about today. But it's not like education and outreach. It's sort of yet another thing. And I think it's another important career trajectory for people to know about.
I don't know. In the last few AASs where we've done this kind of stuff, they've usually had a couple of people from like Northrop or RAND or Ball, the sort of aerospace and engineering side. This year, the panel, the non-academic panel, is just education and public engagement, which I find odd. I volunteered all of our speakers, and they went with that. So that was weird.
Okay.
In previous years, when we've had an actual like in-person poster hall, there were literal tables over by the posters with like little signs on them that said like engineering, data, software engineering, like education, and people with those careers would sit there, and then people would come and chat with those people.
I feel like people like Kristen Shapiro would be so.
Exactly. Kristen, who is my office mate.
She's fabulous, and she would speak so well, and it's a really different path, but it's also really interesting.
So I believe the idea is to have Zoom breakout rooms by career path, but I don't know. The Career Center, like most of the AAS, has been a bit frantic getting ready for this meeting, it seems. So we'll find out on Thursday, I think.
Okay.
All right, so I'm going to end this with a shot. Happy birthday. You didn't have a 21st birthday shot, so if you have a shot, take a shot. And thanks, Jeff. It's good seeing you guys again. I always end my night with a shot. So, everybody, cheers.
Cheers.
Yeah, thank you guys so much for the advice and learning about cocktails. That's cool too.
Excellent. We'll be in the Slack channel the rest of the week, and like I said, there'll be a couple of these other things going on. We do have an email list that I'll put in the Slack channel. We use it basically to announce this event every year. That's the only thing we use it for. But there are some Facebook groups. I think Jess posted a Facebook group that she used to be an administrator of, and I now am, and I totally forgot about that. But that is for astronomers and data science type stuff. So yeah, there's a number of outlets. You should definitely LinkedIn connect all of the speakers and organizers, all that kind of good stuff.
Yeah, I'm not on Facebook, so you won't see me in that group. But if you want to reach out, LinkedIn is a good way.
There you go.
Yeah, I might have a few more questions.
Yeah.
Good night, everyone.
Have a good night, guys.
Bye. Thanks.
Bye, guys.
Bye.